Some of you are responding, which is great. By the way, Mentimeter is another one really useful tool which can be used to do assessments. So in the classroom, since many of our students do have a cell phone, I'm not sure whether all of them have it, but they can sometimes, um, sometimes answer in groups, like they can discuss an answer and share something in groups. So many of you are trying to answer. Okay, many of you are answering. Many of you are saying understanding. So somewhere it is understanding the learner, understanding their potential, understanding their conceptual knowledge, or to know how much they are understanding. Some of you are saying we wish to assess in order to monitor the progress of our students, how much they have progressed, where they were when they started the journey, and now during the semester, how much of progression of their, development has happened. Okay, evaluate the process, to know how much they are learning, to check. Wonderful. So I think we have a good number of now feedback here from all of you. And thank you for sharing this, because this gives us a baseline of where we should start from, right? Um, so now let us move on to the next part where we will try to assess our own understanding, right? I mean, one of the things is, in order to assess someone else's understanding, let us first go through this process of assessment and try to understand how much we have understood. So what we are going to do now is we are going to, overall in this session, we are going to recognize the importance of assessment as a teaching learning tool, and we are going to look at assessments as a tool for making our teaching and especially students learning, because I think many of you were focusing it on how much has the student learned. I want to understand that. How much the student has progressed, I want to understand that, and that's why I'm conducting assessments. But can we shift the goal such that not only to gauge how much they have understood, but can we use assessment as a tool to make students learning the main focus, because that's what our ultimate aim is. So can we change our exams, maybe some of the exam questions, exam patterns, to really ensure that all of it is aiding towards the students learning, right? And let's make it as a collaborative experience, so that will help us improve each other's performance. So here, what we are going to do is we are going to use montillation and uses of Traxolin as one of the lessons that we are going to, learn today. And this may seem a little off. This is not, you may say that it is not the chemistry, and let's see, because let's see whether there is chemistry in it. So how many of us know about montillation and the uses of Traxolin? Can I have a show of hands, maybe in the chat, or just unmute and say? Do we know what is montillation and uses of Traxolin? No?
No,
Okay.
ma'am.
Okay. So that this is great, because then we can all learn together, right? So I'm going to request one of us. So now we are meeting for the second time. So of course now you know me and I know you. So I want you to be more vocal throughout the session, right? So can I request one of you to help me read it? Okay, help me learn it. So I'm going to put a line on the screen, and can someone volunteer to read it out loud? Can someone just unmute and say, I will read? It's just English, nothing different.
Okay, I will read.
Okay, thank you, Alok sir. So I'm going to now show the first line. Okay.
It is very important to learn about Traxolene. Traxolene is a new form of Uniter.
Okay. It's a new form of Xanter. Okay.
It is montilated in Seristana. The Seristana found what they could distillate large amount of ferrone and then break it to quasel Traxolene.
Wonderful. So it is montilled in Seristana. The Seristanians found that they could crystallate large amount of ferrons and then bracter it to causal traxolene. Wonderful. And now the last sentence.
This new, more efficient bractylation process has the potential to make Traxolene one of the most useful products within the molecular family of Leuciges Snidlius.
Yes, wonderful. So thank you so much, Alok sir, because he really helped us learn it. Now that we have learned what is Traxolin, can we answer some of the questions and we can answer together. So let's make the assessment a little easier. I'm going to also keep these sentences here, right? So let us go question by question. I'm going to show the first question and see how many of us are able to answer it. I think all of us will be able to, right? So what is Traxolin? Can someone help me answer it?
New form
New form of Xanter.
Wonderful. Traxolin is a new form of Xanter. Full marks. What about the next one? Where is it montilled?
Seristana.
It montelled in Seristana.
It is montilled in
Seristana.
Seristana. Wonderful. How is Traxolin coaguled?
Distillate large amounts of ferrone.
Okay, wonderful. Tanya ma'am, can you say it out loud?
Distillate large amount of ferrone and then bracketer it.
Wonderful. So we could crystallate large amounts of ferrone and then bracter it to causal Traxolin. Wonderful. And what is the last one? Why is Traxolin important? Why is it important? Can we answer that?
To understand the bacterial process very efficiently.
Okay. Any other reasons that somebody else wants to take a shot at the last one? Last one is a difficult one because remember we started from what, then we went to where, then we went to how, and the last one is why. So according to the Bloom's taxonomy, we are now going from some of the easy questions to a harder question. So why is Traxolin important?
It can be converted to some useful product.
Wonderful. So we can convert it to some of the most useful products within the molecular family of Leucissus neslaus. Right? So all of you were able to answer these questions. I would say if you had given more time, you would have remembered all of this. You wouldn't even need the text here, and you would have scored full points on this exam. 100 on 100. Right? So can I now conclude so that you all are experts in montillation?
No,
I'll
ma'am.
give you a degree that says that you are
No.
experts in montillation or a certificate.
No, ma'am.
No, ma'am, not at all.
No, right? I mean, teaching and assessment did happen. We did look at the paragraph, we did discuss it. We looked at assessment, we answered the questions also, but then did learning happen? And that's a question we have to ask. Doesn't matter if we are talking about montillation or Traxolin. Doesn't matter if we are talking about a concept in chemistry. We could be talking about, conductimetric titration. Did learning really happen? Is the question, right? So what we are going to do is we are going to now look at assessments in a very different manner, such that we are going to start looking at it not as a passive memorization and then regurgitation. So very often in our exams, what happens is, think about the student. Think about the student such that if they are looking at it, right now you're looking at montylation and traxolin, which are new terms. But for our students, some of the terms in chemistry are extremely new to them. Wouldn't they be looking at those terms with the same way? And when they are replicating or kind of reproducing their work in the exam, are they really showcasing their learning? That's a question we all need to ask. And that's why it is important that we look at learning and first think about what is learning. So if we think about what really is learning, it's basically formation of new connections in our brain. For that, our brain has to struggle. Our brain has to, make these new synapses between neurons. And then we have to ask a question, what is really teaching, right? What is teaching? Teaching then becomes a very important way in which we create conditions to form these new synapses in our students' brain, right? So between the two, when our students are learning and when we as teachers are teaching, assessment plays a very important role, because it tells me whether these new synapses are really formed or not. And it also, as a way of my own teaching, I can think about changing my teaching based on what the current response is, right? So learning is really brain change, and that's what we need to do. So here the main thing that we all need to reflect and probably kind of discuss is that what is our primary goal? What is the primary goal of education? And again, if you think about the last talk that we had, we started with purpose of education. But here now, to think about it, it is mainly to help our students learn to think about their own thinking, learn to think about how they are learning or not, so that they can use the standards of the discipline or profession to recognize their own shortcomings and correct their reasoning as they go. So very often my analogy for assessment is like having a Google Map companion. See, when you start a journey, right? When you start a journey, let's say I start the journey from today to go to Amravati, and then I start from the road here, which is the Barnet Road. Then I take the express highway and try to get on the express highway to get towards Amravati. I'm not going to be told by the Google Maps towards the very end, hey, you did not reach Amravati, you have reached Solapur. It doesn't work, right? The Google Map has to be with me throughout. Whenever I take a wrong turn, it should tell me, hey, this is wrong, you need to correct your path. And this happens multiple times. So every single time I go wrong, the purpose of the assessment is to tell me that where am I in my journey to get to the destination. It doesn't happen towards the very end. It has to be with me throughout the journey. And that's what I think NEP 2020 is also trying to say when they are talking about formative assessment, summative assessment. So one of the ways to think about is, how do I know what we know, and how do I know whether my students have learned something? And so we had discussed this classical design last session, which is, your syllabus, you teach using various strategies, and then you assess your students. Instead of that, can we start thinking of going towards, let me just, I think there is a slide that is skipped. Going towards, let me just, give me 1 second. So we were talking about the classical design, where we start with the syllabus, then we look at various actual teaching strategies, and then we go towards assessing our students. Instead of that, can we start thinking backwards? That is, what should my students know or be able to do by the end of the class? And more importantly, what evidence will convince me that they have got there? And more importantly, how will I help them to get there? So this is very simple. The same analogy, the student should be able to reach Amravati, let's say, What evidence will tell me that they have actually reached? When I actually see them in Amravati, right? And the last one will be, how will I help them to get there? And that becomes my teaching methodology. So learning goals, assessment, and your activities have to go hand in hand. And that's where this backward design really is helpful. And we have to think about the process of learning that is linked to the learning environment. So far, we have been mainly focusing over this part, which is, knowledge centered. Does my student know something, some concept, some principles? But more importantly, we have to think about it making more learner centered, such that the the activities in the classroom are such that they can help my learner learn. There are active learning strategies, there is effective instruction, such that I can make them realize how useful it is for their community, right? Towards the world. Again, the purpose of education. And much more importantly, I'm going to think about it where we start thinking about it being assessment centered, meaning not only that my student should know, but more importantly, is my student able to perform a particular task, a particular activity? So this becomes the main crux of, looking at the process of learning overall. And NEP will talk about mainly assessment and evaluation. What's the difference between them? The purpose of assessment is always to increase quality, right? And whereas the evaluation is towards judging that quality. So here, for example, this man is watering the plant with the hope that, the plant grows. He is watering the plant with the hope that we make it grow better, grow taller, whatever is the criteria. But evaluation is basically the person is kind of grading, saying, hey, this is too short a plant, it hasn't grown well, and there are not enough leaves, so I'm going to give it a C minus. Think about the intention of the teacher in these two types of assessment. So one is assessment and the other one is evaluation. One is towards the growth, the other one is towards judging the quality of the growth. Both are important. I'm not saying one is more important than the other, but unfortunately in our education system we give so much importance to this part, the final evaluation, that we don't pay enough attention here. And that is where we need to work on. So another um, good analogy that I can show you when we think about assessment and evaluation is that, let's say today there are some people coming to my place for food, for dinner. And when I'm making the dinner, I'm kind of tasting the soup and then saying, hey, this needs more salt or this needs more pepper. And then I add it to the soup such that the soup becomes better and better. And then the guests also like it, right? So this is more the kind of formative assessment. When I'm tasting the soup before the guests arrive, then this is more a formative assessment because I'm working towards improving that soup. Whereas when the guests come to taste the soup and they say, hey, wonderful soup, or they say, didn't go so well, whatever is their judgment becomes the summative assessment. So here the important part is, can I have more focus on the formative assessment because it's more towards the growth? If my formative assessment is good, the growth is going to happen, and trust me, the summative assessment will also be good. But if I only focus on the summative assessment, I will never know how the quality of the soup is before it appears for the exam or for that summative assessment. And if the quality is really not good, then I have no scope to improve it further. So we need to start thinking about summative assessments and formative assessments in our classroom. So the types of summative assessments could be like exams, papers, presentation. These typically occur at the end of the teaching or end of the semester or end of a particular period, right? And this is mainly the usual major part of the grade for the class. On the other hand, if we think about formative assessment, we are looking at classroom assessment, things that happen in the class during the lecture. This could also homework or online assessments. They happen during the teaching. That is the main part where there is a scope for the teacher to know how much they have learned and course correct. So your role is here is that of the Google Maps, right? If you see a student going wrong, this is the time where you can tell them, hey, you need to do it right. And this is the place where we provide regular feedback to both instructor and student. So this will tell me whether the student is able to do something. This will also tell the student how they are doing on that. And so when we think about assessment, what NEP is really requesting you to do is that so far we have been focusing mainly on this. This is assessment of learning, right? What is assessment of learning? Meaning I'm learning or I'm assessing how much the student has learned, which I think many of you said during our first Mentimeter poll also. I want to know how much they have learned, how much they have understood. But instead of that, can we start using the assessments for learning, students learning, and more importantly, students start seeing the focus of assessment as learning. So this is assessment for learning. That is how much has the student learned. It also tells us about how much we need to improve in our own teaching. And assessment as learning is when the students start seeing their assessment not as something that they are dreading, not as something, hey, आज भी एक test है नहीं करना यार, not like that, but instead of that, or being afraid of the test, I don't know what is going to happen. Instead of that, can they start looking at it as a part where they start enjoying it, where they start saying, hey, let's try this. If I don't get it, maybe I learn something better, and let's see what I learn. So can we start looking at assessment overall in the form of assessment of learning, for learning, and as learning? And just to illustrate what we mean, off learning means it is giving me a kind of metric, how much the student has learned. Whereas as learning helps students to distinguish between what they know and what they don't know. So it is the students who are doing their own assessment here. And more importantly, when we think of assessment for learning, this is when the assessments can aid the construction of learning for both, for the teacher as well as for the student. I'll give you an example. So for example, so far, we design tests where we ask a question about a particular concept, and let's say okay, so I'll give you a concept. This is about, let's say I ask a question about how the oxidation and reduction in cyanotype blueprinting work, and this is a very standard question. This is a redox reaction. Students will have to think about how it works, why we develop a color, and they will answer that, right? Instead of that, I now give written responses to my students. They work in groups, and I ask, I'm going to do cyanotype blueprinting, but here are the modifications in this particular process that I have done. Let's say in the first one, I've changed the time of exposure. In the second one, I've changed the amount of sunlight. In the third one, I've changed the concentration. Now you work in groups and you tell me if the prints will be better or they'll be worse. What will be the effect on the printing of things? So now they have to work together in the group. They have to think about how the cyanotype blueprinting will really be affected. And in this process, they're going to learn something much more than what I could have, covered in the lecture. And this particular thing is also going to tell me how much they understand, where are the gaps in their understanding. And this particular exercise, although it is seen as an assessment, it becomes an assessment not of how much they already know, but it becomes an assessment for both of us, where I know what they know and where they will start looking at it from the point of view of learning something more, right? So one of the ways we can make the thing more engaging for our students is we can ask them to brainstorm. We can think about clicker questions or Mentimeter that we just did, right? Where we ask them to do some kind of decision making, where they work together towards solving a particular problem, where they start with group exams or 1 minute paper. One of the really things that I really like is this, towards the end of every class, I ask my students, can you write down one muddiest point? Now, what is a muddiest point? So let's say I've taught a particular concept in this class, right? Muddiest point is when their mind is completely muddy about that particular concept. In Marathi, it is gadhul, right? Meaning it's not clear. This particular concept of the entire lecture didn't really understand it. So they write that down and they try to kind of tell me why they feel it is the muddiest point, but they hand it to me at the end of every class. What does this help me with? I kind of, it's hardly like a 1 minute thing. I ask them to think, write it down on a short piece of paper, hand me towards the end of the class. What do I get to see? I get to see how each person is basically uh, kind of doing in their understanding. It is their gauge. Probably somebody who says, I haven't understood this, doesn't really completely understand how much they have understood. But more likely, when a student says, hey, I haven't understood, you should trust them because they are really good. So when I asked you, for example, are you experts in montilation? Many of you said, no, I don't think so, because you were kind of telling me how much you have understood, right? So what this tells me is also how the class overall is doing. So when I come to the next lecture or next class, if there is a particular concept that has appeared in multiple people's muddiest point, I know that I need to first address that towards, before I go to the next one. So 1 minute paper tests are really amazing. You have think pair share where the students can think between a pair, like discuss it with their partner, discuss it with somebody in their class, and then discuss it with the whole class towards coming to a consensus. Okay. So when we think about chemistry particularly, this is where the main problem of assessment is, right? So let's discuss now more towards chemistry. Until now, we were discussing overall what can be done. But now, if we think about chemistry, very often in the lab or in the lecture also, we are discussing what we see at the macroscopic level, meaning something that we observe. Here I have given the example of iron rusting, right? So we see a process around us, the iron is rusting. It was nice and shiny before, and now it has formed this brownish, powdery rust around it. Very often we ask our students to focus on that when they are really doing an experiment, when they are really doing a particular lab. For example, did the solution change color? Did you see effervescence? Did you see or did you get a particular smell, or did you there are various different ways in which we do observations in the lab, but very often they are based on what we can see. There is a color change, there is a precipitate form, there is a effervescence, there is a gas evolved, whatever, something that you can see and observe. But why is it really changing is a reason, basically, that is what happens at the submicroscopic levels. What happens, why is that brown powdery rust seen, is that there is a change happening submicroscopically in the structure of iron. Why? Because there is a chemical reaction happening. And very often we don't really focus on this. We don't gauge our questions such, or make our questions such that they gauge what is happening at the submicroscopic level, right? And that is where we need to think about how we design our questions. Can we make questions that test students' understanding at this level? And very often we do ask questions. For example, you could say, explain me the process of how iron rusts, or draw or show me a reaction that represents how iron rusts. But then it is mainly students writing 4Fe plus 3O2, so on and so forth in the exam. A student being able to write this in the exam does not tell me if they have really thought about the submicroscopic level. Because a student can very easily, wonderfully, just memorize this. 4Fe plus 3O2 plus 6H2O giving 4FeOH whole thrice, right? That does not tell me if the student has really understood the chemistry behind it. And so we need to think about how we design our questions. We need to think about how can our questions be something more than representation. Very often our students are focused here, that is macroscopic observations. Teachers are mainly focused here, which is representation in the text or in the paper. But the real chemistry, unfortunately, happens here, and that is where we need to focus our attention on. So that's why these two things have to aid towards gauging their understanding at the submicroscopic level. Let's think about the chemistry lab, for example, and this is where I really voice my concerns about how we evaluate our labs, right? So think about a chemistry lab. This is a very generic standard chemistry lab, and think about it. You are entering into this lab for the first time, or you're trying to perform a particular practical, right? It could be any practical of your choice. What are some of the things that will come to your mind? Think about it from the point of view of a student. Can somebody unmute and tell me what comes to your mind when, or what might my students be thinking when they start thinking about doing a lab?
For chemistry lab, bad odor.
Chemistry lab, any chemistry lab.
Fumes, color change.
Okay, so they could be saying, oh, there are too many things around me. There are like fumes coming from this flask. Okay, there could be a color change in the reaction that is happening. What else is your student thinking as they are in that lab? Think about it for a, I mean, we are very used to the lab, so we know, we are very comfortable with it. But think about it from the point of view of a regular student who is joining in your first year. What is the first thing they will think?
They may question
Ma'am, safety.
where
Safety. Okay, so the first thing they could be thinking is, hey, no, there are just too many chemicals around me here. I should be safe. That's a wonderful thought. Okay, what else will they be thinking?
they may think where these experiments will be useful. That is the application
Okay,
part.
where this, what am I going to do in this lab? Where these experiments are useful. Okay, what else?
They are curious. They are curious about the different instruments. They
Wonderful. So they will ask,
see
hey,
their,
this flask looks different than the other one.
yeah,
And if, what is this instrument that is plugged?
yeah.
And why is this particular burner, kind of attached here? Things like that. So they will start observing things around them. Now start about, let's say the student starts performing the experiment. What all is going on in the student's mind? So let's take a very simple experiment of HCl and NaOH titration, because that's what we all can easily say that all of us have done it and we know what happens. Think about what the student has to do when they are really working on that experiment.
Some will think what crazy thing that I could do.
Okay, so they will first read and then they will say, hey, I need to, what I have to do, right? So, for example, I have to now measure 10 ml of this HCl into this flask. Where is the measuring flask? Am I being careful enough such that I'm pouring it in? Hey, is it 10 ml or am I going a little above? If it is pipetting, it is even more difficult, right? So then their mind, think about the mind that is happening, what is happening in the mind of the student is completely focused on what is happening or what they're doing with their hands, right? 10 ml लिया के 11 ml हो गया कि उसको कैसे कम करूं, how do I pour it properly such that it doesn't fall, right? Or I don't break the glassware, or I also have to write down the observation side by side. I also have to talk to my partner about which step they are doing. Think about the mind of the student and how crowded it is at that point. Does your student have the time to think what chemistry is really happening? Very often the answer is no. The student's brain is so focused on doing the part rather than thinking about what is happening in the reaction. And so, what they term chemistry lab, and it is true for all labs, it's not just about this particular one experiment, but think about a synthesis, for example. You have to do so many things. You have to think about so many next steps. I don't want to increase the temperature. The temperature has to be controlled. I want to add this dropwise only. I have to prep for my next step, which is, dissolving something into some other liquid, and then I have to add it to my synthesis. So many different things. And the students are reading the procedure as they go, right? They are not like, they don't memorize the procedure before coming to lab, and that is not possible also, and that is not really recommended also. But what happens is this makes the chemistry lab a very complex learning environment. So when we think about learner's point of view, when we think about what is happening in the student's brain, it talks about integration of knowledge, skills, and attitudes. We have to think about how much the student already knows, whether they are able to do something with their hand, whether they are able to make observations, and also their attitude about doing it. Like, so when somebody said that their first concern will be of safety, of course. So, what is their attitude towards safety? What is their attitude towards mixing things? What is their attitude towards collaborating? A lot of these things will matter. And it requires coordination of different constituent skills, qualitatively different. Being able to perform is not being able to reason out. It's not being able to write it down properly. So there's a lot of different constituent skills that are coming together. And they have to also transfer or apply prior learnings to real settings. So all of these are extremely difficult things for a new learner. When an experienced learner like you all will step into the lab, a lot of these things will be taken care of. But when our students are doing it for the first time, they are thoroughly confused. Their brains do not have the time to think about the actual chemistry that is happening, right? And so, if we think about the skills, knowledge, and attitude in our labs that we wish to develop, I will just talk about the knowledge, and maybe you can talk about the skills and attitude. We wish to help our labs work with them on their fundamental concepts. We want them to learn experimental design. We want them to learn safety and compliance. We want them to learn data analysis, maybe, right? All of these is what are learning outcomes. I after doing this lab, I hope my students learn some fundamental concepts of acids and bases, let's say. After doing this lab, I hope my students appreciate how the experiment was designed, they understand how the experimental design works, and I hope that they are able to analyze the data. When it comes to skills, do they have the technical proficiency? Do they have the problem solving skills? Do they have the hands-on skills? Again, experimental design, data management skills, collaboration, communication, critical thinking, right? So these are all the things that we hope our students learn from the lab experience. Can somebody help me with the attitude? What kind of attitude do you feel students will develop after doing a lab?
Yeah, I think first of all, we normally try to give an handout to the student that what next exercise we are going to do. So at least they should be, read properly when they come to the lab. And then second, before committing to the lab or in the lab, we go through a kind of discussion. Okay, so you read it. So now we understand what are we going to do. So these are the points, and that you have to look out these things in the experiment. So normally, and then we start almost if it is 4 hour class.
Yes,
So
so
one
there is
hour,
a pre-lab
one
part,
hour,
which is
1 hour
wonderful.
we give for the discussion. We demonstrate, we tell them, and then we give a demo. Teacher is doing, and the students are observing, and then
Yeah,
we ask them to perform the exercise. So
exercise.
that's a normal practice we follow in our college.
Wonderful.
Thank you.
So this is actually a standard practice in all most of the labs, right? There is you do want your students to read the thing before coming. You do want them to also there is a discussion happens before the class, so we call it the pre-lab talk here. Even after that, when the student is actually doing the experiment, very often their brain is focused on doing the experiment. That's what the research finding right now tells us. It is very common, like irrespective of how many times you have done a titration, when you're actually performing a titration, your brain, majority of your brain's focus goes on, am I handling the equipment right? And that is, you will also appreciate, think about yourself when you're doing the lab. You will also realize how much of your brain is engaged in the procedure rather than thinking about the chemistry. And
Absolutely.
That is true. That's how the whole experience works, unfortunately, right? But when we think about attitude, we do want students to develop scientific temperament. We do want them to think responsibly about the lab and its uses. We do want them to do resilience or develop resilience and adaptability. We want them to have appreciation for teamwork, lifelong learning skills, chemistry, society values. All of these are kind of the broad outcomes that we want at the end of any chemistry course, right? Or it could be towards a chemistry degree. But the truth is, can we now start thinking, are we addressing any of these in our assessments? Very often, our assessments are focused here. It's conceptual understanding that we try to test. We ask them questions, what is the reaction happening? Or can you explain me this process? We may be asking them questions about safety. We may be giving them some data analysis to perform. We give them a question that they can solve in the classroom. That this is the reading after 10 titrations. What do you think? Is it good data, bad data? Things like that. But we hardly ever work on these two forms when it comes to assessment. Of course, some of you might be doing some of it, but it doesn't come out explicitly as one of the core domains of assessment, especially when we look at the broad population of teachers, right? So can we work on that? Can we make our questions such that they rather test critical thinking rather than memorization of concepts, right? So one of the questions that we all should ask ourselves is, do our assessments really assess these, right? So let us observe this particular experiment carefully, okay? I'm going to show you a very simple experiment that we all have done probably. And this is a test from, I think, 10 standard. So it's one of the easiest ones. Yeah. So what I'm going to do here is that I'm going to add some water into this particular petri dish such that it is full of water. Now on one side, I'm going to add some potassium iodide, and on the other side, I will add some lead nitrate. Right, so lead nitrate and potassium iodide I have added too, and we'll see what happens as the reaction progresses. Has any of you done this experiment? Right, so what is happening? Can somebody tell me the observations? I'll just fast forward it. Can someone tell me the observations?
Data arrays is formed in the
Yellow.
interface.
Yes.
Yellow color.
Yellow color is forming. There is a yellow line forming. And if I shake it, then it is going to form a yellow liquid altogether. Right? So that's our observation. Can somebody remember what kind of reaction is this?
Double displacement.
It's a double displacement reaction. In fact, we have it in the 10 standard syllabus, Ki plus lead nitrate giving you potassium nitrate
Yes.
and lead iodide. And the lead iodide is the compound that is yellow in color, right? Now think
Yes.
about it. Let's say that I ask my students to do this particular experiment like this, that take 1 second. So now let's think of it this way, that I start with this particular experiment and I give a procedure to my students. Add this, perform this, put water, add Ki, add lead nitrate, and then perform this experiment. The students are kind of focused on doing something that is being told to them. I'm telling them the procedure. But now, can I change the assessment question such that I ask them to think about various parameters that will affect the reaction? For example, I could ask them, what factors do you think will affect the position of the reaction front? So can you tell me what are factors will affect the position of that yellow line?
How well it's soluble once it is in
Okay, so
the
solubility of the compound. What else? Temperature, wonderful. Any other factors that come to our mind?
concentration.
Concentration. Okay.
Concentration.
Okay. Any other thing? There are many
If we
other
are
things
mixing, so it's a direction, how we are mixing.
Okay. The shape of the flask maybe. Will it affect? Whether
Also
it's
the
a
mixing
solubility. Solubility. Okay, solubility we have already said. What other things will affect the position?
mixing ratio. How much
Ratio,
amount of
mixing,
chemicals?
right? So
Flow
for example,
velocity.
and then I ask you to design an experiment to test the effect of one of these factors, let's say temperature, on the position of the reaction front. Now think about from the point of view of student, that when they had to blindly follow a procedure to a point where they get to design an experiment to test the effect of something. So now they have to think about, what all readings will I take? Should I take the, let's say I'm taking the effect of temperature, right? So for example, should I take the readings of ice cold water at 10 degrees, at 20 degrees, 30 degrees, 50 degrees? Or should I just take 3 readings? So you're not telling them what they have to do. They have to think about what they will do and get back to you. Right? So there is a change in the decision making. There is a change in the ownership of the experiment suddenly, because you are asking them to come up with the experiment design. Of course, if my student says that, hey, I want to do this particular reaction at a very high temperature, I probably will say, no, let's not do it. Let's try to limit it up to 70. So I'm not giving them a complete freedom, but they do have a freedom where they get to be the experiment designer for the first time. They have to think about what are the different independent variables, what are dependent variables, right? What are controls? So let's say I'm checking the effect of temperature. I should keep my concentration constant. I should I should keep, let's say, the water constant. So if I use DI water versus water that is already having some salts, it's going to change the way this particular reaction happens. Idea here is giving more ownership in the assessment itself also to the student, because that is the only time when the assessment will start becoming a learning experience for the student. Because the moment my student comes out of this particular assessment, they are going to think, hey, did I design it right? What are my results saying? Why does it happen really faster at higher temperature? And does it increase linearly with does the rate increase linearly with the temperature? Does the position change linearly with the temperature change? So on and so forth. They have to think, they will start thinking about, how does really this temperature affect the position? Not because they are more involved in it, not only because they are more involved in it, but they had the freedom to design the test. They had the ownership of the experiment, and that is what we should get to. It can happen in very simple experiments also. So for example, I can probably tell you that diazotization is one experiment that we typically do. And I give them a grid of dyes. Let's say that I form the dye A1 when I do the reaction with aniline and beta naphthol. and I form di-A2 when we do the reaction of aniline with Schaeffer's acid here, right? Very simple again, the same way the diazotization will happen. But then I ask them to predict. They have not done the TLC yet, but I asked them to predict, hey, can you predict whether A1 will rise above A2? Can you predict the polarity? And how will the solvent polarity affect the RF? Can you predict the effect? So let's say that I am going to do this reaction not only in ethyl acetate and water mixture, but I am also going to do this particular reaction in hexanes only. How do you think the RF value will change? Now they're not really doing the experiment first, they're first predicting. They have to justify their prediction. So if they say that I run this TLC in hexane, the compounds will not rise, they have to first justify why they think so. Then let's say I allow them to do this experiment such that they run their TLC in hexane and they see that it is not rising. Then they have to explain why, whether their prediction was right or wrong, or so on and so forth. So predict, observe, explain also becomes a very easy method in which they can be more involved, because when they are predicting, just like how gambling is somewhere where you get hooked on to, hey, will my bet come right or wrong? When they're predicting, they get more involved in that particular process. So you can employ predict, observe, explain to pretty much any experiment that you're doing in the lab. I could, for example, ask them that this is how the conductivity curve for NaOH and HCl looks like. Can you predict it for acetic acid versus NaOH? First predict, then perform, then explain if your prediction was right or wrong, right? So we can change the way we structure our questions in the lab, definitely. And this is where we start, going towards this particular Bloom's taxonomy, where we, instead of just remembering and making them think about how to define or list or memorize or repeat or state, we start going towards, can they classify, can they describe, can they explain, can they execute, which is there in the lab, can they implement, can they solve something, can they differentiate, can they relate, compare ideas, can they argue, can they defend a particular thing, and towards the final thing, can they design something, can they construct something? So this becomes a very important thing, and that is where I want to see whether we can go. So here is a particular experiment in front of us. I think many of us have done it before. It's a simple acid-base titration again. So here in the flask, we have HCl at the bottom with the BTB indicator. And as we add NaOH from the top with the burette, we are going to come up with a color change. First it looks green, then it turns blue. Blue is the end point of this particular titration. So now what I want you to do is, can you tell me a few questions? So suppose, imagine that this is the particular titration you have done or you are going to do, right? What questions will you ask based on this particular experiment? So I'll give you 2-3 minutes, at least come up with a couple of questions, right? So I'm going to, it's 11:38 right now. Let's come think about it till like 11:40. Come up with a few questions. This is a simple acid-base titration, okay? So come up with a few questions you will ask your students.
Hello.
Should we discuss? Or do we need?
Yes.
Okay, so let's now try to map our questions. So many of you have written some wonderful questions in the chat box. So can we try to create a map? So can somebody tell a question that they designed?
Even use.
Sorry? Just can you just speak out a little louder?
What is meant by endpoint?
So what is endpoint, right? So you what and is, so I'm going to put one tick mark there. Okay.
What is the volume of NaOH used? What is the
So
value of
what is the
P1O2?
volume of NaOH used, HCl used? What is the indicator? All of those questions will come in this bracket yet. Okay.
Why the color is changed after adding some amount, not
So
in
why
initially.
did the color change, right? So we are going to tick mark there.
So maybe we can fragment into two ways. One is the procedure, another is the concept.
Okay.
Procedure is they have to follow this as this, and then they have to observe and see the change in the chemical reaction. All
Right.
chemistry.
Yeah.
What does the
So
indicator work?
question. What is the question, Archana ma'am, that you designed?
Yeah. Question would be, yeah, for the if I have to see as a procedure wise, so first I'll say, like, fill your burette and make sure there should be no funnel at the top of your burette. Secondly, when you are observing the reading should be like, whether it is lower meniscus or upper meniscus, eye level,
Archana ma'am,
burette. Yeah.
we have to design questions. So can you tell me a question that you will ask as an assessment of this particular procedure?
Yeah, if I have to assess, I'll ask, how would you observe the reading?
So
So
how did you observe the reading, or how would you observe the reading? Okay.
how? Yeah. So
Okay.
that would be the question in the procedure part. Then what should be the flow of NaOH when you are putting into the acid? And
What is the flow of NaOH?
right. Then we can think of when the color change. What is the point where you feel the color can change?
So when did the color change, or
Yeah.
when does the color change?
Yeah,
Okay,
yeah,
so we
yeah.
are going to put a tick
So
mark there.
yes.
Okay.
Yes.
Any other
So
questions somebody else would like to now add to the list?
How does the indicator work?
What is the indicator? What is the role of the Sorry?
Meniscus? How will you read the meniscus?
How will you read, or how is the
How will you
meniscus
read the
read?
meniscus in the
Okay. How
burette?
is the meniscus read?
Lower
Okay.
meniscus or upper meniscus?
Upper meniscus. Okay.
How is the
Any other
meniscus read?
questions?
Why we use
Structure of the
conical
indicator
flask?
in acidic and alkaline medium.
So what is the structure of the indicator?
Why we use conical flask instead of beaker?
Beaker. So why did we use a conical flask instead of a beaker? Right?
Yes.
Okay.
When did you stop the titration?
When did you stop the titration? Okay. So I'm
why
putting
some molecule, sorry, why
wherever
some molecule behave like an indicator?
So why can, let's say, BTB behave as an indicator? Wonderful. Or why does BTB
How
behave?
many, ma'am, how many readings would you take to get a concordant or an accurate value?
Okay, how many readings would you take? Wonderful. Okay. So, wonderful. Thank you so much for these inputs, because if you think about it now, if I start with the highlighter here, these are basically, this is a question grid. What is, where did, when can I, who can, who would, right? And so on and so forth. And this is very useful whenever we are making questions for anything. Not only this titration, this can be used for any other experiment. This can also be used for any other exam that you write. But the truth is, the lower order questions are all kind of centered around this area. Okay, this is where your brain doesn't have to think much and can answer just based out of memory. What is the indicator used? I memorize it as BTB. Yes, wonderful. What is the amount of NaOH used? I memorize it as whatever 25 ml. I can just answer it. On the other hand, the questions that really require you to think and can go more towards this particular quadrant. And you will then start thinking about questions that can. So for example, how might the readings change if instead of doing the reaction at room temperature, I do the titration in a hot condition? You have to now think about a lot of different things before answering this question, because it cannot come out of memory, right? Or how might the indicator color change if I modify the indicator by changing some of the functional groups on that? You have to now start thinking about something more than what is told in the particular thing. Or very simply, how will you represent the flasks before the endpoint and after the endpoint? Can you show me how these molecules look before and after? And why do we see that green color in between a yellow and a blue? Why do we see in blue? Can you, or how will you represent it? How will you represent the molecules in the green flask? How are they different from the blue flask, and how are they different from the yellow flask? So the moment I change towards my question such that I go towards this side of the triangle, it becomes more and more thought provoking. And that is where I want you to all probably answer my next questions. You could just unmute and tell me, as a teacher, do you ask questions to your students? Yes, no.
Yes,
So these
ma'am.
are
Yes.
just mainly yes,
Yes,
yes.
ma'am.
Definitely yes.
Yes,
Yes, ma'am.
wonderful.
Yes.
When do you ask questions?
While they are performing.
While they are performing.
Before starting the experiment also.
Before starting the experiment. Wonderful. Are these oral questions or written questions?
No.
Oral.
Oral.
Oral mainly,
questions.
ma'am.
Oral.
For what purpose do you ask questions?
For the understanding.
For gauging the understanding. Okay.
Just to know what the students know about the experiment also. Ma'am, basically
Process.
Process.
Just
Okay.
to make them start thinking.
Just
or
to
more
get them to
engaging.
start thinking. Wonderful. Do you write out in advance the questions that you ask them?
Sometimes, yes.
Okay. What kind of questions do you tend to ask?
Yeah, if some thought-provoking questions, so then I have to think about it. Procedural questions sometimes which come very natural to us, so that's we don't have to. But sometimes we think, yeah, we have to give a little tough one, then we have to think about it, pre-plan.
Wonderful. What kinds of answers do you tend to get?
In general, most of the students will not, but you get to know, like, few students are really sharp. So out of 50, I expect 1 or 2 students to give me that kind of answer.
Okay. What do you predict would happen if you change the kind of questions in your classroom itself? What criteria could you use to assess the effectiveness of your questions? How will I know if my questions are good or bad? And how could you collect data on and analyze your questioning patterns and the impact of different kinds of questions on your students' learning? And I'll also now go over why we went through this set of questions and why did we have this conversation around this topic. Is now start thinking about all the questions that are asked here in this particular slide. What do we see? The first question, as a teacher, do you ask questions to your students? You had to just answer out of your memory. This was at a remembering level. Do I ask questions? Hey, yes, I ask questions, so I'll answer yes or no, right? Or when do you ask question? Again, it's a set procedure in my lab, so maybe before, after, during, right? Whatever it is. Oral questions or written question, again at the remembering level of Bloom's taxonomy. For what purposes do you ask questions? This comes little more towards understanding. You had to think, why do I ask questions? And do you write out in advance the questions you ask? Again, it comes to remembering. What kind of questions do you tend to ask? Now you have to analyze your own question and answer that. What kind of answers do you tend to get? Again, analyze. But the reason why we had much of the silence towards the last three is because you could not answer that just based on memory or lower Bloom's level. You had to actually think a lot. If you have to answer these questions very critically, you first as a teacher would have to think a lot. What criteria would you use to assess the effectiveness of your questions? You'll have to evaluate your own questions, come up with criteria, and then tell me, Neeraj, I will use these criteria, and then I will know if my questions are good or bad. But to come up with that answer, it's not in your memory, so you cannot come up with it very quickly. You will have to think about it and then answer. And last one, which asked you to collect data and what experiment will you do on your own questioning patterns, you have to actually think about creating. So think about how the responses right now went. When I was doing the first 4 or 5 questions, many of you were answering. Then it came to 1 or 2 people being able to, quickly come up with an answer. Towards the end, we did not have enough time, or we did not have enough time for us to discuss this properly, or you to think properly to quickly come up with the answer. So if I want my assessment or my learning outcomes to go in the direction of Bloom's taxonomy, my assessment should also go in this direction. It cannot go in any other way. I should have some questions that assess at this level. I should have some questions that assess at this level, some at this level, some at this level, and very few at this level, right? Then I will know if my students are able to reach to the destination that we wanted all of them to reach. And so instead of just question, think about closed. We are always typically asking these closed-ended questions. Can we think of some open-ended questions that we can ask in the classroom? So open-ended questions basically don't have an unrestricted answer. They don't have a very specific answer. But they generate meaningful and comprehensive answers. They very often require collaborative work in the team towards coming up with that answer. And the students have to own their ideas and feelings and let it flow and work together towards coming up with the answers of an open-ended question. So identifying, naming, defining, etc. will mainly assess memory. But I can go ahead and I can start towards assessing convergent thinking, which is, explain state relationships on why, how, in what way. And I could also assess divergent thinking. How broadly can my students think? Imagine, suppose, predict what will happen if you change this, what will happen if you change that. And then we can also think about evaluative thinking, which is valuing or defending or justifying a particular thing. Right? And all of these are very important. So can we think about analyzing our own question papers and see whether we are focusing more only on this portion or whether I have enough of this portion as well? That is where we want to go. And in our classrooms, we can think about atypical assessments also. So what is atypical? Something that is not typical, something that is not pen and paper or oral based, right? When we are thinking about atypical assessment, think about various things you can change in the assessment. We have discussed a lot about questions, so I'll not go over that questioning part, but think about the mode of the assessment. That is, in the written pen and paper or oral test, can there be a different mode? Can I ask them to submit a video? This is something that we had talked about when we were thinking about digital pedagogy. Can we ask them to present? Can we ask them to create a tarsia? Can we ask them to create a new, crossword puzzle? Make a crossword puzzle, get it to the lab. If you come up with a good crossword puzzle that no one is able to solve, you get more marks, right? Or things like that. Basically, can we change the mode in which the questions are asked? Can we change the role in which the question gets asked, or who is answering the question? So for example, I could ask them to, instead of individually answer, I could ask them to work in a small group and present your answer as a group. Or I could say, hey, you ask me a question, I'm going to try and answer, and you have to evaluate how good my answer is. right? So the role of the teacher and student is exchanged here. Or I give them a written answer that I designed an experiment in these ways. You evaluate the flaws in this experiment design. The role of the student is suddenly changed. And the more important part is, can we change the purpose of assessment? And that's something that we started with at the start, that can we go back from only looking at it from the summative assessment point of view, but can we now start thinking about assessment as a part and parcel of our everyday life? Can it be only for fun? Why should we grade each and every assessment? Let's say we make these wonderful Tarsia puzzles. Let's have some fun in the classroom and just solve these puzzles. Let's not go towards actually grading and evaluating how each student did on the Tarsia puzzle. So can we change the purpose of the assessment also? And that is where, again, coming back to the Bloom's taxonomy, can we design assessment, digital taxonomy? Can we design assessments that
Madam,
are...
sorry to interrupt. What is
Yes.
Tarsia puzzle?
In my last one, we did look at how to make a Tarsia puzzle. I'll go over it again if need be, but it is in the, I'll just type it in the chat box. Did anyone get a chance to try the Tarsia? From the last lecture to this lecture? So
Not
Tarsia,
yet, ma'am.
No,
Not
so
yet,
do
ma'am, but
try it.
I believe we remember it very clearly. I personally remember it very clearly.
Right. So if you go to tarsiamaker.co.uk, what it can ask you to do, let me just see if I have a Tarsia Maker open here. Here. Right. So if you see this is a Tarsia Maker, and here I can write a question and write the answer to that. Right. So it
Yes,
becomes
I
a
can.
jigsaw
No,
puzzle.
no, no. Now I can recall.
Now you remember, right? So it becomes a jigsaw puzzle. But in the classroom, sometimes it is good to also, you know, do it as fun. Why don't we do it as fun? Let's play some games. Let's play, so very often I use Bamboozle, where we use it for assessment, but the students are just divided into teams and it becomes a quiz. Like they are very competitive in that manner, like who gets more answers and things like that. So it becomes a part of our revision. I don't grade them on how well each team did, and I don't use it for my final grading also, but it becomes a part of their experience where they get to revise the concepts that they have done. We could also look at using some of these things, tweeting or mind mapping or posting or podcasting. Can I use it to for my as a part of my assessment? So we have to make it more atypical. We have to make it more informal. Add the fun quizzes, add the fun homework, add some concept checks, add some in-class observations. We have to make it ongoing. It cannot be only done at the end of the semester. It has to be towards where the students are involved in it every day. There is a responsive teaching. I change my teaching based on what the students are giving me answers of. And there is also has to be a very great self-evaluation. So that becomes a very critical part. And it can be also asynchronous. It doesn't have to be always in the classroom with the students. I can give them something fun to do as homework, and then it becomes an asynchronous assessment. For example, when I am teaching the shapes of different orbitals, I ask my students, hey, whenever you are going around the campus, and just click a photo of a shape that resembles a particular orbital and send it on this particular link, which is for the class group. And then the students will find a balloon that is inside a balloon, and then they send me, hey, this is 2s, this is a 2s orbital and in it I can also see a 1s orbital and things like that. But why am I doing this assessment? It's definitely not such that I'm not gauging their skills to really identify orbitals, but one of the reasons behind this assessment is I want them to start thinking about these orbitals. I want them to start memorizing the shapes, but also more importantly, I want them to think about these orbitals even after they've left the classroom. So when this assessment becomes in this format, go around and click pictures of different objects that resemble orbitals, they are not only looking at it from the point of, or they don't leave their thinking behind in the classroom. They're carrying it with them when they're going around. The learning becomes much more concrete. So think about how can we make our assessments much more atypical, informal, ongoing. The final and formal assessments are with you. The final exam is not going to change because I know it's not in your hands. It's not in my hand also. But the in-class assessment can be much more fun. And it can also aid towards learning, which will result in a great final assessment score for your students. So, this is the journey that we want our students to go through. Like they start with, they don't really even know what they know, but they get to a point where they start knowing what they know and what they don't know. So can we get our students to go from, I don't know what I'm thinking, I don't know what you're saying also, but at the start of the semester, which is a very cloudy mind, but towards the end, hey, now I know this very well and I can solve problems on this one, but I also know that I probably don't know this very well. So can they be metacognitively aware? And in order to do that, one of the easy ways to do that is to give them some criteria. And these criteria of assessment becomes very clear to us and our students. The more clear they are, the easier it is for students to check their own understanding. For example, let me ask you a question that we want to gauge this particular model's dress. So I want you to rate it. What will you rate it? Out of 10? You can put it in the chat box. You can also unmute and talk. What grade will you give this particular model's dress? Nine. So Sudhanshu sir wants to give 9. Salim sir wants to give 7. Archana ma'am says 9.
7.
7. 8. 8. 8. Great. So many of us are giving between 8 and 9. We don't want to upset the model. 7. Okay. Because it's also a good dress, right? Okay. So now, if I now ask you to change it, or rather to give a criteria, consider the dress our model is wearing and rate it in terms of its suitability and color. Now your answers may differ from what you have given already. Because earlier you were not focusing on the color. Now you have to focus on the color and give the answer, right? Or I can now change the question that consider the dress our model is wearing and rate it in terms of suitability and color with our model skin and frame. Specifically for a winter season fashion show, you would probably rate it higher because he's wearing a sweater. But now if I had that question as a summer season fashion show, you would suddenly drop your rating to like 2 or 3, right? You cannot wear this dress in summer. Or such that this particular person is going and teaching in a university classroom. Is that okay? Probably yes, probably no. You will again base it on the criteria that you have. And now I will give a very clear instruction that rate it from the criteria of 1 to 4, where 1 is low and 4 is high. So having this idea of what my criteria is, what my rating scale is, becomes very easy. It becomes easy for me to know whether learning has happened, and it becomes very easy for my students to also know whether learning has happened. For example, I could make a rubric that looks like this: suitability for the color and for teaching in the classroom. Yes, no, yes, no, yes, no, like, or 1, 2, 3, 4. You could rate it such that it could be this. I don't know. I'm just saying. But then I have a very clear way to grade how this model did, right? So, and this is true for any particular task that our students are doing in the lab or in the classroom, doesn't matter. For example, I can tell my students that if you are able to solve this question such that you give me the correct answer up to the 3rd decimal point, you will get 3 points. If the answer is off by this much error factor, you will get 2 points. If it is completely off, you will get 1 point. Or I will give you this question to solve. If you are able to solve it in 5 minutes, you will get 2 points. If you are able to not solve it in 5 minutes, you will get 0 points. Now, I'm not only assessing the students' ability to come up with the right answer, I could also be assessing students' speed to get to the answer, or I could be looking at the solution the student has written and are all the steps written. Yes, you have these many points. Are some of the steps skipped? Lower number of points, and so on and so forth. But basically, I will have the rubric to assess my students on a particular test very clear to me. And it is also very clear to my students. That is the most important part. Because I should know that you are going to grade me on jumping 5 feet for me to be able to jump 5 feet. That's what I will try. Right? One of the very bad examples to give here, but it is actually the suitable example. You have all these guidebooks, right? Or we had all these guidebooks for 12th standard, that if the answer is written like this, you are likely to get more points, right? That is what our students used to think like. It's not the best way, but somewhere that clarity is important, that for me to get full points on this particular question, I need to be able to write it down in this manner with these steps, with this much correctness or accuracy towards the end, right? And this is where we have to talk to our students about what is expected and what will be assessed. Because rubric brings a degree of clarity and precision. Rubrics also guides us to design our own instructions, and rubrics make the learning target more clear. I want to be able to reach Amravati. That is my target, right? But now the target is also such that I should be able to reach Amravati in 5 hours. Then my learning method differs, then my delivery method differs, right? Rubric makes the assessment process more accurate and fair. Or rubrics provides students with a tool for self-assessment and peer feedback. And rubrics definitely have a potential to advance the learning of students. So all of these are very important when it comes to assessing the learning of students. So a typical analytical rubric will look like, I will state my criteria and what it says about each standard. Excellent में कब बोलूंगी, good कब बोलूंगी, competent कब बोलूंगी, adequate कब बोलूंगी. So for example, critical and creative thinking skills. Uses critical and creative at a high degree of effectiveness, average, lower, so on and so forth. Quality of argument and writing, right? The argument is complex, original, the writing is strong, will give you 80 to 100% of the points. But the argument is simple and unoriginal, and writing is weak and inconsistent. I'm only defining how I'm analyzing my students' writing, right? So you can think of it from this manner. Can I make it more and more clearer to my students? Make the criteria clear, make the standards clear, and make the descriptors clear, right? And so when we have to think about overall our assessment, let us reflect on, how do you know when you know something, whether you have understood something, and how do you know when your students know something? These two are really important for us to address. And how do your students know when they know something? Because that is how we can make our students lifelong learners. It cannot be just with, they cannot have you all the time with them. They cannot have a complete, guidance all the time with them. So how do your students know when they know something? And that's why this alignment between test questions and learning goals or outcomes becomes very important. We don't want to be here where we start with our instructions, where we start with our thing, and then we realize, oh, jana to yahan pe tha. It's not aligned, right? In fact, it should be something like this, where we know where we are going. All of us are going in that direction. So the test questions, the activities, everything is towards that learning goal. So design questions to align them with learning goals. Consider various learning levels and design questions to test higher order cognitive level. And one of the easiest way to do it is actually with an alignment table. So I can start with a learning objective based on basically what will my students learn. The outcome is, if they have learned it, what will be the students able to do? This could be like, solving a particular problem, performing a particular titration, performing a particular synthesis. The assessment is, how will my students demonstrate that they know or be able to do it? They should be able to perform the titration in front of me, and then I will know if they are able to do it. Or they should be able to find out the flaws in someone else's titration methods, then I know that they are able to do it. Or they should be able to, you know, teach someone else on how to do the titration, and how well they do it will tell me if they really know able to do it or not. The learning activity is what will the students do in order to learn it. So they will perform the titration themselves. They'll try to teach it to their classmate and then see if their instructions are clear enough. Things like that. So can I have this alignment between learning objective, outcome, assessment, and the learning activity? And that becomes really important. So I'm going to end with this last slide, which is very important. And all of us as teachers need to think about it. I'm going to read it out loud. So assessment is probably the most ignored part of good teaching. You will also understand why. Is that because we focus on syllabus, we focus on what happens in the classroom. So it is often the most intimidated to the instructors. I'm intimidated also to the instructors and the students. It becomes one of the most difficult part of the learning journey. It need not be difficult if it is integrated into the teaching in natural ways that include both large and small assessment events. Once instructors become familiar uh, with the iterative process of assessing, teaching, and reassessing, and of teaching students to evaluate themselves, teaching without ample assessment feels like, groping in dark, and it's hard to imagine teaching without it. When assessment becomes a very core part of your own teaching, you will start realizing that it is impossible to teach without a formative assessment, because without it no learning can happen. So with that, I'm going to end today, and I hope that all of you will ponder more on this, and will come up with more ways to strengthen the assessment in your classrooms. Thank you so much.
Thank you so much, Dr. Nirja. It's really wonderful, and I think you have really helped us in designing our class much better. I have a question to ask. We have a class where students are of different strength in the sense in their capacity,
ability.
So
Yes.
how should we design? For some the class is very easy, for some it's okay, for some it is really tough. How we should design our question in that that we should be able to assess them.
Absolutely. So this becomes tricky again. If I'm doing a summative assessment, it is easy for, it is very difficult for me to have different levels that the students will find it challenging, right? So in the final exam, I try to always, so I also have a vast diversity in the classroom. I try to get it such that there are some questions that everyone in the class is able to answer. So this is like 40% of my test is such that if you have studied enough, if you have, these are basic questions. The next 20% are somewhere it gets to a higher level where only a portion of the students get to answer that. And the 10% I actually keep it to a point where even I find it difficult to answer. So this becomes even challenging for really good students. But this is much, much easier to address it in the formative assessment, because in the class, if I design assessment such that I say, take a concept from the syllabus and design a particular presentation on it, or you try to teach it to somebody else, then what happens is the students who are good will because they are interested in learning, they themselves take a difficult concept. There is a lot of autonomy in that particular whole assessment design, that the good students will then try to go towards higher ceiling. So we always call it low threshold, higher ceiling. Low threshold is what everyone should be able to do, but those who are good can go towards higher levels. Yes.
Right. Thank you so much. Thank you.
Yeah. Thank you, ma'am. Thank you, everyone. I think if there are any questions, again, you have my email. Please write.
Thank you,
Thank you,
Nirja.
ma'am.
Thank you so much. Yes.
Yes,
Thank you, ma'am.
ma'am, if you could permit, shall we conclude with the session, ma'am?
Yes, absolutely.
Now, may I request Dr.
Yes.
Rupali ma'am to please propose vote of thanks. Dr. Rupali ma'am,
Yes,
please.
yes, yes. respected Nirja Dashpute ma'am, esteemed faculty coordinators, and fellow participants. Very good afternoon to all of you. On behalf of UGC MMTTC, Sant Gadge Baba Amaravati University, Amaravati, being a participant of this refresher course, I am Dr. Rupali Talegaonkar, present here to propose the vote of thanks. First, I extend our deepest gratitude to our esteemed resource person, Dr. Neeraja Dashputre ma'am, Principal Technical Officer Education, Academics, ISER Pune, for time out of her busy schedule to be with us today. Ma'am, your insightful session on assessment in chemistry, basically on assessment purpose and strategies, was truly eye-opening. And you also focuses over modulation and uses of trexolene. And we are deeply appreciative of the practical examples and innovative assessment methodologies that you have shared with us. Your lecture has undoubtedly enriched our knowledge and given us fresh perspective to apply in our respective taking fields. I must also take this moment to thank our course coordinators, Manisha Kodape ma'am, Director, UGC HRDC, Santa Amravati University, Professor Dr. Muhammad Atik sir, for organizing this UGC sponsored refresher course in chemistry. Thank you for your tireless efforts behind this scene to make this session a seamless reality. A special thanks to our technical team and support staff for ensuring everything that will run perfectly. Finally, a big thank you to all the participants for our enthusiastic engagement and interaction. And lastly, thank you once again, Nirja ma'am, for your invaluable contribution. We hope to have the privilege of learning from you again in the future. And lastly, wishing everyone a wonderful session ahead. Thank you.
Thank you.
Thank you, ma'am.
Thank
And
you.
with the kind consent of Dr. Nirja ma'am, I would like to declare that this particular session will be over. Thank you so much, ma'am. And thank you, participants.
Thank you.
Participant, please stay connected. We will continue for the next session as soon as our next expert has joined with us.
Okay.
Hello, Professor Sherekar, ma'am.
Hello, madam. Hello.
Yes, ma'am, you are audible. Shall we start, ma'am, if you could permit?
Yes, please.
So, friends, good afternoon once again. As we are going to the final part of this refresher course in chemistry, today we're going to talk the very much important aspect, the role of academia in the incubation. Friends, you know that one of the graduation outcome has been moving from this NEP, that is the NEP 2020 National Education Policy, towards the startup and the commercialization of our technology. And the Maharashtra government, and not only the Maharashtra government, the government of India has taken the several initiatives towards the skill development as well as the entrepreneurship development. And one of the important component in this entire era is the incubation center that has been established by the different universities, institutions, and some clusters incubators are there. So what is the role of these incubators? In this entire ecosystem, we will going to talk. We will going to discuss in this much in this session with the help of one of our renowned and the scholarly and the senior expert, Professor Swati Sherekar, ma'am. Ma'am, first of all, I extend my warm welcome on behalf of the Malviya Mission Teacher Training Center, Sant Gadge Baba Amravati University, and all the participants, those who have gathered from the across country. And now may I request, first of all, Dr. Rohit sir to please briefly introduce our expert speaker, and then we will start with the session. Yes, Dr. Rohit ji, please.
Yeah, thank you, sir. Good afternoon, everyone. I am Dr. Rohit Kholia, an assistant professor at Department of Chemistry, Deshbandhu College, University of Delhi. It is my great honor and privilege to introduce our distinguished resource person for this session. On behalf of the UGC Malviya Mission Teacher Training Center and Sant Gadge Baba Amravati University, under the able coordination of Professor Manisha Kodape ma'am, I extend a warm and heartfelt welcome to Professor Swati S. Sherekar ma'am. Professor Sherekar is a senior professor in the postgraduate department of Computer Science and Engineering and the director and head of the Incubation Center at Sant Gadge Baba Amravati University. With over 25 years of experience in teaching, research, innovation, and academic leadership, she has made remarkable contributions to higher education and technological advancement. She has published more than 140 papers in international journals and 26 papers in national journals, receiving over 1700 citations and achieving a Scopus H index of 24. Her contributions to innovation are equally impressive, with 8 patents, including a UK design patent and 8 copyrights in emerging fields such as artificial intelligence, machine learning, cloud computing, and cybersecurity. An inspiring mentor and academic leader, Professor Sherekar has successfully guided 12 PhD scholars and supervised numerous postgraduate research projects. She is also leading prestigious funded initiatives, including a 5 crore DST supported technology business incubator and a 2.5 crore Startup India Seed Fund project, fostering innovation, entrepreneurship, and research excellence. Her outstanding contributions have been recognized through several prestigious honors, including the national level Brigadier M.L. Anand Award, IET 2023, and the Outstanding Lady Engineer Award and the Woman of the Year Award. She is a fellow of IET and a lifetime member of IEEE, CSI, and ISTE. We are truly privileged to have such an accomplished academician, researcher, mentor, and a visionary leader with us today. I am confident that her expertise and insights will make today's session both enriching and inspiring for all of us. Ma'am, on behalf of the organizers and all the participants, I extend a warm welcome. We sincerely thank you for accepting our invitation and taking the time to join this faculty development program. We eagerly look forward your insightful and inspiring lecture. With these words, it is my privilege to hand over the virtual platform to Professor Swati S. Serikar, ma'am. Ma'am, we look forward to learning from your valuable insights. Over to you, ma'am. Thank you. Ma'am, you are not audible. Please unmute yourself.
Thank you, sir. Thank you for the nice words. And as you have mentioned from my profile that I'm basically senior professor in computer science, but I'm playing the another most important role in the university that I'm working as a director innovation incubation and linkages. Along with I am leading my incubation center as a director and head of the incubation center from last 6 years. So this particular experience I want to share with all of you because it is the mandate of the government nowadays to focus on the startups and the skill programs. Now, all of us belonging to the teaching fraternity, whether you belongs to chemistry, physics, maths, or any of the discipline, government it is asking us the outcome based education. OBE is there. Now, in what respect or the aspect we are counting our output in terms of the research papers, the patents, the research scholars, projects. That's all. What we are treating our output in terms of the number of research that you have guided. But beyond that, suppose all of you are belonging, and most of you might be the doctorate, having your own PhD. Then after that, once your PhD has been awarded by your university, what next you have done towards your research journey? That you will say that now I have registered myself as a supervisor and now I am guiding my research student and few number of students those have awarded in my mentorship or in my supervision or in my guidance. That's okay. That is always there. But as per the time, the era, there is a demand that we must focus now on the skilling part, apprenticeship part, internship part, industry linkages, and whether we are able to develop any product out of our research. That should be our intention so that we are able to fulfill our guidelines. And that is more than that, we will get the satisfaction that we have ultimately able to derive something which is useful for the society. My research, it is useful for the society. It is the remarkable thing. And it is the milestone to you, to your department, to your college, and ultimately to your university. And it will get counted in every aspect for the accreditation, for NAC or the NRF or anything what you are want to count yourself in the competition for the grading and the competition in the academics. So here I want to emphasize on the role of incubator in the academics. Most of you might be aware about the incubator and some of you might not be aware about the incubator. But government has given now the clear cut mandate that in every institution there must be the incubation center or the pre-incubation center. Here in our Amravati University, we have taken or drawn one particular direction that each and every college, they must have the pre-incubation center. Now, previously, we used to term this particular center as ED cell or the IIC center or the E cell, or likewise, the different nomenclatures are there. All these cells, they used to do certain industry linkages and placement, and somewhere they used to have certain move forward regarding certain industry based projects, or likewise they used to do certain job related to deriving certain output or project oriented thing. Now on the same line, we want to do the work for the innovation, incubation, and then the linkages. Now in this case, जैसे आप लोगों को पता है एनईपी के गाइडलाइन में देयर इज अ कंपल्सरी क्लॉज ऑफ रिसर्च मेथोडोलॉजी फॉर एवरी पीजी कोर्स, and for every UG course there is a GOEC, then IKS, then CC. All these different verticals we are covering in our syllabus. The aim behind all these verticals that the student must have the knowledge of the different domains. Different domains, along with that, the basic core subject, whatever you are learning. जैसे एक स्टार्टअप का मैं अगर बात करना चाहूँ, आप लोग देखते हैं कि बहुत सारे स्टार्टअप्स जो यूनिकॉर्न्स है, और बहुत सारे स्टार्टअप हमको भी मालूम है कि जो आज बहुत अच्छा काम कर रहे हैं, यूनिकॉर्न्स बने हैं. यूनिकॉर्न्स यू माइट बी नोइंग, जिनको हम कहते हैं कि $1 बिलियन के ऊपर जिनका टर्नओवर है, वी यूज टू टर्म देम एज द यूनिकॉर्न्स. नाउ in the domain of innovation, the India is doing the marvelous job. कैसे? That every year worldwide the innovation index it is calculated, and India it is standing at the 3rd position worldwide in this particular innovation index. Means India is doing a very good job in the field of innovation. Not only that, we are moving quite far ahead in this particular domain of the innovation. जैसे कि मैंने अभी कहा यूनिकॉर्न्स, तो इंडिया में कितने यूनिकॉर्न्स है? जो मैंने लास्ट मंथ में फिगर देखा था, इट इज 118 यूनिकॉर्न्स आर देयर इन अवर इंडिया, जिनका $1 बिलियन के ऊपर टर्नओवर है स्टार्टअप का. जैसे फ्यू ऑफ द नेम आई वांट टू टेक, Big Basket, Ola, Uber, then Zomato, Swiggy, Urban Clap, Licious, Cricket का आपका वो. There are n number of unicorns. I can Nika. ऐसे नाम गिनाते बैठूं तो बहुत टाइम इट विल टेक. द लिस्ट इट इज देयर ऑन द नेट. यू कैन फाइंड आउट द यूनिकॉर्न्स फ्रॉम द इंडिया. नॉट ओनली इन इंडिया, जैसे हमको पता है यूएस में भी इंडियन पॉपुलेशन बहुत है जो कि वहां पे काम कर रहे हैं. उनके यहाँ पे 365 जो यूनिकॉर्न्स है, उसमें से 78 जो है यूनिकॉर्न्स, दोज आर ऑफ द इंडियन ओरिजिन्स. मीन्स इंडिया में तो काम कर ही रहे हैं, एंड अक्रॉस द ग्लोब जो इंडियन से काम कर रहे हैं, दे आर ऑल्सो कॉन्ट्रीब्यूटिंग इन द फील्ड ऑफ इनोवेशन, इंक्यूबेशन एंड द स्टार्टअप्स. मीन्स हमारे पास में टैलेंट की कोई कमी नहीं है. और बेसिकली हम जो अपने डे टू डे लैंग्वेज में कहते हैं कि जुगाड़ टेक्नोलॉजी, एक पर्टिकुलर प्रॉब्लम पे हमको अगर सोल्यूशन चाहते हैं हम लोग, तो विद द परमुटेशन एंड कॉम्बिनेशन एंड द बेसिक नॉलेज वॉट एवर वी हैव, वी यूज टू फाइंड आउट द solution on that particular thing. Means innovation, it is there in our blood. So this particular platform gives you to scale yourself, to prove yourself as a successful entrepreneur, and to grow yourself. Once you grow, the one particular startup grows, the incubator is also able to grow in a multifolds. So how incubator works, I want to focus on that, so that all of you will get acquainted. And once you are relieved from this particular course, when you join your parent institution, you can take lead to establish the incubation center in your university or in your college. सो जैसे हमने एकेडमिक के पॉइंट ऑफ व्यू से देखा कि किस तरह से हमको इंक्यूबेशन सेंटर की मदद हो सकती है इनटू द एकेडमिक्स, जैसे एनईपी का मैंडेट है, इंडस्ट्री लिंकेजेस है, इंटर्नशिप है, अप्रेंटिसशिप एम्बेडेड प्रोग्राम्स है, सभी के लिए हमको इंडस्ट्री कनेक्ट चाहिए। उसी हिसाब से जो मोस्ट इंपॉर्टेंट एस्पेक्ट है टू grow our student or nurture our student as a startups. So startup हमने जितने भी, मैंने few of the names I have taken, but the list it is you can find out the on net also. और हम अगर स्टार्टअप इकोसिस्टम का अगर स्टडी करते हैं और कोई भी हम उसमें स्टार्टअप लेते हैं तो we are able to see that the most of the startups, they are in a team of 2 or more. Whether you are able to see my screen.
Yes, ma'am.
So, innovation. Oh,
Madam, can you make it full screen?
yes, yes, yes. स्क्रीन दिख रही है that I am sharing?
No, ma'am.
No, madam, it's gone now.
Now it is visible.
Is it visible?
Yes, ma'am.
Visible, madam. Please
Okay.
make it full screen.
Yes, ma'am.
First of all, tell me whether it is visible.
Yes, ma'am, visible.
Yeah. So now we are discussing the innovation, incubation, and the startup. Startup के journey में the role of innovation and what is the role of the incubation. Innovation, how will term the innovation? Innovation और invention इसमें फर्क है. जैसे innovation, it is the creation of something new जो कि already existing है something. We want to do the better in terms of the product, in terms of the service, in terms of the method, process, or any idea which has a novelty, that we can treat it as a innovation, and that particular idea must have certain value and the impact. That particular creation we can treat it as a innovation. अब उसमें नॉवेल्टी भी होना चाहिए, उस पर्टिकुलर आइडिया को कुछ वैल्यू भी होना चाहिए, उस पर्टिकुलर आइडिया का कुछ इम्पैक्ट भी होना चाहिए, And there are, in terms of the different services, different processes, different product, you can treat any of these as the innovation. जैसे हमने कहा कि ओला, उबेर, जोमेटो, स्विगी, पेटीएम, भारत पे, बिग बास्केट, लिशियस, अर्बन क्लैब, all these are the different startups. Some of them, they are the products, some of them, they are providing the different services. So, जैसे हमको अपना एक इंक्यूबेटर तैयार करना है, तो हमको क्या क्या करना पड़ेगा? जैसे मेरे यहाँ पे जो इंक्यूबेशन है, दिस पर्टिकुलर इंक्यूबेशन, इट इज द सेक्शन 8 कंपनी, जो कि कंपनी एक्ट के अंडर में काम करती है. अब कंपनी का एक्ट है, तो वहां पे डायरेक्टर्स है, board of directors are there, and I am working as a managing director and the head of the incubation center. And our honorable vice chancellor, it is the chairman and director of this particular company. And along with this, there is a shareholding pattern, because the initial investment, it is done by our university into this particular company. Therefore, it has a shareholding pattern. Now, once this particular structure it is formed, why this particular structure we have formed? Because we are out of bureaucracy. Now, all of us are working under the bureaucracy. There are pros and cons in the bureaucracy. We don't want to discuss all these things, but the different advantages what we are getting out of this particular company formation and running under the company, that it has autonomy, and we are able to do all these operations in a very multifold speed, that the exponential speed we are able to take the decisions, and we are able to take or implement the decisions. Therefore, we want the faster output. Suppose I want to do the MOU with any of the industry, I can do all the legalities, but the speed it is faster as compared to our bureaucracy, because in our bureaucracy there are lot of different stages and the different committees we need to go through, along with the legal, along with the permission, and then later on you will have the MOU on the stamp paper, then the notary, and all these things are there. So we are also doing the same thing, but it has a faster way of doing the things. That is the foremost thing why we are running under the Section 8 company. Section 8 company, it is the non-profit company, means it is not a profit-making company. So this is one particular way of the thing establishing the incubator. Then in my incubation center, I have received 5 CR funding from the state government through the MSINS, that is the Maharashtra State Innovation Society. Then another 5 crore ka sanction I got through the central government under the DST ITBI scheme. And along with that, a third project we have received from the central government, that is the SISF, that is Startup India Seed Fund. From these 3 different funding, we used to give the seed funding to our startups. Not only the seed funding, the incubator support for the different facilities that each and every student need to establish his company. जैसे मेरे स्टूडेंट के पास में कुछ आइडिया है, which is a very innovative idea, and which it has a value, and it will give also the impact on the society. Now, if he approached to you as a faculty, then you must suggest him to go to the incubator for further hand holding. There is a difference between just a support and the hand holding. Incubation center, it is meant for the hand holding. Now, if he approached to the incubation center, we used to guide him. जैसे उसको पहला क्वेश्चन है उसको कि आई वांट टू फॉर्म द कंपनी, जैसे आप लोगों ने उसको सजेस्ट किया कि योर आइडिया इट इज वेरी गुड, इट हैज अ नोवेल्टी, इट हैज गुड इम्पैक्ट, यू मस्ट एस्टेब्लिश योर स्टार्टअप। तो वो इंक्यूबेटर के पास में आएगा। इंक्यूबेटर में देन ही हैज अ बिग क्वेश्चन इन फ्रंट ऑफ हिम। मुझे बोला गया है कि यू नीड टू एस्टेब्लिश योर कंपनी। सो व्हाट सॉर्ट ऑफ कंपनी आई शुड एस्टेब्लिश, कहाँ पे जाना पड़ेगा टू कंपनी फॉर्मेशन, व्हाट आर द डिफरेंट डॉक्यूमेंट्स, व्हाट आर द डिफरेंट पोर्टल्स, और कौन से टाइप की कंपनी मैंने करनी चाहिए। जैसे देयर आर एन नंबर ऑफ डिफरेंट टाइप्स ऑफ कंपनी, ओपीसी कंपनी इज देयर, एलएलपी कंपनी इज देयर, प्राइवेट लिमिटेड कंपनी इज देयर, एंड अल्टीमेटली डीपीआईटी इज देयर। सो मैंने किस टाइप की कंपनी करनी चाहिए वो भी उसके सामने बहुत मिस ऑफ थॉट्स आर देयर। तो उसको प्रॉपर गाइडेंस चाहिए। तो जिस टाइप का उसका रिक्वायरमेंट है, जिस टाइप का उसका प्रोडक्ट है, उसका प्रोडक्ट का स्केलेबिलिटी कब तक कहाँ तक है अक्रॉस द ग्लोब, वेदर ही इज एबल टू ग्रो और विद इन द जुरिडिक्शन और द लोकल है, या किस टाइप का उसका आइडिया है, बेस्ड ऑन दैट the incubator can suggest him what sort of company he must establish. So to establish that particular company, incubation center will take the complete responsibility of establishing his company. Once that particular company he has established, later on he must seek the authentication validation of the startup, that he must register himself on the Startup India portal. Once he has registered himself on the Startup India, then that particular company, it is a legitimate or validated startup, and this particular company now technically it is called as the DPIT registered company, जो कि डिपार्टमेंट ऑफ इंडस्ट्रियल ट्रेड के पोर्टल पे जाके मिनिस्ट्री के थ्रू उसको एक रिकग्निशन मिलेगा, उसको एक डीपीआईटी नंबर मिलेगा। नाउ वी विल ट्रीट दिस पर्टिकुलर कंपनी एज अ स्टार्टअप। और स्टार्टअप को बहुत सारे रिलैक्सेशन दिए हुए हैं गवर्नमेंट ने, जैसे इनकम टैक्स में रिलैक्सेशन दिया है, देन जीएसटी में रिलैक्सेशन दिया है, प्रॉफिट गेन टैक्स में रिलैक्सेशन दिया है, देन जहां पे भी टेंडर के थ्रू कॉम्पिटिशंस हो रही है, then the priority should be given to the startups. Likewise, lot of different facilities it is given to the startup to compete with the rest of the industries. Along with that, these particular startups, they are able to have the different facilitation just through, जैसे हमको आईपी फाइल करना है, मेरा जो इनोवेशंस है, आई नीड टू फाइल द आईपी फॉर दैट इज द इंटेलेक्चुअल प्रॉपर्टी राइट। मैंने उसका पेटेंट लेना चाहिए, कॉपीराइट लेना चाहिए। तो ये जो हम हर एक जो इनोवेटर है उसको हम सबसे पहले सजेस्ट करते हैं कि यू मस्ट हैव द पेटेंट ऑफ योर आइडिया। ये जो पेटेंट फाइलिंग, पब्लिशिंग एंड ग्रांटिंग तक सभी जो प्रोसेस है, इसके लिए गवर्नमेंट के डिफरेंट फंड्स है। सो गवर्नमेंट इट इज ऑल्सो हेल्पिंग यू टू फाइल योर पेटेंट सो दैट यू विल हैव योर ओनरशिप ऑन योर आइडिया। जैसे अगर मैंने कोई पेटेंट नहीं लिया और मैंने मेरे प्रोडक्ट के रिलेटेड काम चालू रखा और मैंने प्रोडक्ट लाया मार्केट में, within next month I am able to see that another company has started producing the same product and they are claiming that this is their innovative idea and they have filed the patent against that idea also. Now this originator, he can't claim that this idea it is mine, because you have lost your opportunity of filing your patent before producing that particular product. तो सबसे पहले आपने अपने आइडिया का पेटेंट लेना बहुत जरूरी है। तो ऑल दिस फैसिलिटीज द इंक्यूबेशन सेंटर इट इज प्रोवाइडिंग थ्रू द डिफरेंट patent sales or the IP wings, those they are having within their incubation center. There are certain onboarded patent attorney also. They can give you the complete IP landscape, उस domain में क्या हुआ है, patent patentability search and all that different facilities you need, they will provide to you. Now, once you got all these peculiar legality, ये पूरा लीगल पर्टिकुलर प्लेटफॉर्म आपका अगर क्लियर है, तो फिर आपका कंपनी रजिस्ट्रेशन में भी आपका कंपनी का नाम यूनिक होना चाहिए, आपका लोगो यूनिक होना चाहिए, आपका किसी के साथ में कोलाइड नहीं होना चाहिए. उसके लिए भी आपको पूरा लीगल सर्च करके लेटर ऑन यू नीड टू हैव योर रजिस्ट्रेशन. तो आपका ट्रेडमार्क भी बनेगा, वो भी आपका आईपी के अंडर में आता है. आपका जो भी यूनिकनेस है आपके प्रोडक्ट के अंडर में कुछ फॉर्मूला है, वो भी आपका पेटेंट के अंडर में आएगा. तो all these different services, it is also provided to the different startups, those who are approaches towards the incubation center. Once all this legality, the formalities, it has been cleared, now the particular startup need certain space to work, to establish his office. He must have certain platform to communicate with the rest of the world. So incubation center, it is providing him the resources like the co-working space, his official address, जो कि incubation center होगा. From that incubation center, he is able to communicate with the rest of the world. He can hold different meetings in the incubation center, different meetings room, can have the different platforms to show different investors through the pitches to his product. जैसे आप लोग शार्क टैंक देखते होंगे. शार्क टैंक इट इज वन पर्टिकुलर प्रोग्राम जो इंडिया में होता है. जैसे यूएस शार्क टैंक भी है, इंडिया का भी शार्क टैंक है. लाइकवाइज शार्क टैंक के जैसे नाउअडेज देयर आर फ्यू मोर प्रोग्राम्स. तो शार्क टैंक के सामने जो स्टार्टअप्स है डिफरेंट, वो अपने आइडियाज पिच करते हैं, और सामने बैठे हुए जो इंडस्ट्रियलिस्ट है उनके पास में एम्पल मनी है, एंड दे वांट टू इन्वेस्ट देयर मनी, बिकॉज वो पड़ा पड़ा मनी तो ग्रो होगा नहीं. दे वांट टू ग्रो देयर मनी, देयरफॉर दे are ready to invest their money into the promising startup, जहां पे उनको पोटेंशियल दिखता है. this particular product has very good potential. They are ready to invest their money into that particular product. और ये जो स्टार्टअप है, ये स्टार्टअप का भी इनिशियल स्टेज में उसको भी फंडिंग की जरूरत है. तो they will have one particular deal amongst themselves, and then this particular startup also can give the counter offers, and once they are agree on that particular deal, they will have one particular agreement. Based on that, the investor, they are ready to invest certain 50 lakhs 1 crore based on the product potential, and they will have one particular agreement within themselves. Same way incubator, it is also doing the agreements with the startups. They are also investing their money. Fund of funds are there, seed fund it is there, then angel investors are there, then certain venture capitalists are also there. They are ready to invest their money into the startups. So this is the one particular aspect. Then if the particular startup need, अगर वो प्रोटोटाइप लेवल पे है, प्रोडक्ट लेवल पे आया नहीं है, तो उसको कुछ लैब्स लगेंगे टू वर्क इन दैट पर्टिकुलर लैब. ही नीड सर्टन गाइडेंस, मेंटरशिप फ्रॉम द लर्नेड प्रोफेसर्स. हियर यू कैन प्ले द इम्पॉर्टेंट रोल. You can get your registration in the incubation center as the mentor. Incubation center can give you the mentorship that is onboarded mentor into the incubation center, और वो आपके प्रोफाइल के लिए बहुत ज्यादा काम आएगा आगे चल के, that you are working as a mentor for the different startups into your incubation center. So these are the thing, different facilities the incubation center it is providing to the startup, including mentorship, workplace, funding and networking opportunities. जैसे network it is very essential to grow your business. अगर मेरे पास में बहुत अच्छा प्रोडक्ट बना हुआ है लेकिन मुझे सेल का चैनल चाहिए, अगर वो सेल्स का चैनल नहीं है, मार्केटिंग प्लेटफॉर्म नहीं है, तो मैं मेरे इंडिविजुअल लेवल पे आई एम नॉट एबल टू रीच आउट टू द कंप्लीट वर्ल्ड, क्योंकि मुझे मल्टीफोल्ड एक्सपोनेंशियल ग्रोथ चाहिए. मेरा पोटेंशियल है, मैं 10, 20, 25 लेबर लगा के आई कैन प्रोड्यूस एज पर द डिमांड, जो कुछ भी प्रोडक्ट है मेरा. सो आई वांट द डिफरेंट ऑर्डर्स फ्रॉम द rest of the world, from globally. Suppose I have that much potential, I can have the different orders from the rest of the world also. So this particular network it is very essential. जैसे आप देखते हैं कि पिचिंग कंपटीशन में या शार्क टैंक में भी जैसे दे कमिटेड that I will invest only the 50 lakhs, but against that you can use, that is the huge help for that particular. They are providing their network to this particular newly emerging startup. That is the power of the network. And therefore in every aspect, जैसे हम टीचिंग में भी देखते हैं, अपना रिसर्च का एक नेटवर्क होता है, एकेडमिक्स का एक नेटवर्क होता है, सेम वे इंडस्ट्री नेटवर्क का भी बहुत बड़ा डोमेन है जहां पे नेटवर्किंग होता है. और कोई भी प्रोडक्ट है, किसी का भी सेल्स है, किसी का भी आपको एक विजिबिलिटी देना है, जैसे कि ये जो पर्टिकुलर पिचिंग इवेंट में व्हाट दे आर गेटिंग, दे आर गेटिंग द विजिबिलिटी. अगर मुझे कोई डील मिलती भी नहीं है वहां पे उस पर्टिकुलर प्लेटफॉर्म में, स्टिल आई एम वेरी हैप्पी, क्योंकि मेरे को नेशनल लेवल पे, इंटरनेशनल लेवल पे सब लोग देख रहे हैं, मेरा प्रोडक्ट देख रहे हैं. लेटर ऑन ऑल्सो दे आर एबल टू कनेक्ट विथ मी थ्रू माई मेल ID एंड थ्रू माई कॉन्टैक्ट नंबर्स, थ्रू माई पोर्टल. वहां पे अगर मुझे डील नहीं भी मिली तो लेटर ऑन ऑल्सो आई एम हैविंग लॉट ऑफ अपॉर्चुनिटी टू हैव द डिफरेंट डील्स फ्रॉम द globally from the rest of the world. So facilitating the networking, it is center going for the collaboration is also one of the important aspect. Now क्या गोल होंगे? गोल तो अल्टीमेटली यही है कि मैंने सक्सेसफुल एंटरप्रेन्योर बनना है. तो उसके लिए मुझे जो जो भी डिफरेंट फेसेस है, फैसेट्स है ऑफ सक्सेसफुल एंटरप्रेन्योर, वो पूरे एंगल से मैं उस पर्टिकुलर स्टार्टअप को हेल्प करने के लिए कमिटमेंट. अगर मैं सक्सेसफुल होता हूँ एज अ स्टार्टअप, तो एंड उसका भी पैटर्न दैट पर्टिकुलर इंक्यूबेशन स्टार्टअप की, जो उनके ये स्टार्टअप की भी हो गई, इंक्यूबेशन की भी होगी. Along with that, one important aspect one must focus, that we are also contributing towards the society through creation of the jobs. जैसे हम बच्चों को प्लेसमेंट के पॉइंट ऑफ व्यू से देखते हैं कि मेरे कॉलेज में मेरी डिपार्टमेंट से इतना प्लेसमेंट हुआ। तो हम माइंडसेट ही ऐसा बनाते हैं स्टूडेंट का कि उनको नौकरी करना है, सर्विस करना है, जॉब्स देखने हैं। तो जैसे ही उनको डिग्री मिलती है, पोस्ट ग्रेजुएशन की हो या पीएचडी होने के बाद में, दे स्टार्टेड सर्चिंग फॉर द जॉब्स, फॉर द प्लेसमेंट instead of job seekers. Now this particular startup, they are the job givers to the rest of their students, their fellow friends, their peer persons. So सोसाइटी में भी उनका इम्पैक्ट होगा। और हर एक स्टार्टअप को एटलीस्ट 10% लेबर तो लगते ही है। वहां पे टेक्निकल मैन पावर भी लगेंगे, लेबर भी लगेंगे, अकाउंटेंट भी लगेंगे, ऑडिटर भी लगेंगे, IT पर्सन्स भी लगेंगे। So in this way also we need to see that you are creating the jobs, you are offering the jobs to the rest of the students. This is also one of the contribution of the startups towards the society. So journey of the startup also we need to see, जहां पे उसके पास में कुछ आइडिया है, वो आइडिया लेके आपके पास में आएगा, then faculty need to give him the proper guidance. आपके लेवल पे ही आपको, जैसे TRL लेवल्स होते हैं, जो आइडिया से लेके प्रोडक्ट तक, देयर आर TRL टेक्नोलॉजी रेडीनेस लेवल के 9 लेयर्स है। 9 लेयर्स में से I want to share that also. Just a minute. These TRL levels are important. Therefore, I am sharing. Whether the screen is visible?
Yes, ma'am.
These are the
Yes, ma'am.
different TRL levels. जैसे 9 layers are there. First basic layer, it is your idea. Concept है आपके पास में, आपको उस concept पे, idea पे काम करना है। तो काम करने के लिए आपको you need to have the basic research. अभी तक ये क्या काम हुआ है, प्रोडक्ट कौन से लेवल पे है, एंड व्हाट बेटरमेंट यू कैन गिव टू दैट पर्टिकुलर आइडिया टू इन फॉर्म ऑफ द प्रोडक्ट, दैट इज योर इनोवेशन। देन टेक्नोलॉजी फॉर्मेशन फॉर दैट पर्टिकुलर प्रोडक्ट। आपने कुछ बनाया तो उस पर्टिकुलर जो कुछ भी मॉडल बना हुआ है आपका, उसको वैलिडेशन लगेगा। तो this is the technology level 3, TRL level 3. TRL level 3, 4, 5 तक भी आप डिपार्टमेंट लेवल पे कर सकते हैं। एंड लेटर ऑन उसका जो MVP लेवल है, मिनिमम वायबल प्रोडक्ट है, एंड commercialization of that particular product, later on you can forward this particular student to the incubation center from the TRL level 5 to TRL level 9 for fully developed product. तो ये TRL लेवल हम लोगों को मालूम होना चाहिए कि जो कि अपने पास में स्टूडेंट आते हैं कि सर मेरे पास में ऐसा आइडिया है, मैं इसका क्या करूं, किस डायरेक्शन में जाऊं, इसका मुझे रिसर्च के पॉइंट ऑफ व्यू से जाना चाहिए कि इनोवेशन के पॉइंट ऑफ व्यू से जाना चाहिए, प्रोडक्ट के लेवल पे मैंने जाना चाहिए। तो इट इज द ड्यूटी ऑफ अस एज अ फैकल्टी, एज अ प्रोफेसर, टू गाइड हिम properly in which direction he should move forward. अगर उस पर्टिकुलर रिसर्च में आपको प्रोडक्ट पोटेंशियल दिखता है तो यू मस्ट गाइड दैट पर्टिकुलर स्टूडेंट, यू शुड अप्रोच टू द इंक्यूबेशन सेंटर फॉर फर्दर गाइडेंस सो दैट यू आर एबल टू डेवलप योर आइडिया इनटू द प्रोडक्ट। जैसे कि हमने देखा है कि देयर आर डिफरेंट TRL लेवल्स, तो 3-4 लेवल तक तो बच्चा आप ही के पास में है, आपके डिपार्टमेंट में, आपके कॉलेज में। आफ्टरवर्ड्स जो कुछ भी उसको हैंड होल्डिंग चाहिए, यू कैन पुश दैट पर्टिकुलर स्टूडेंट टुवर्ड्स द प्री इंक्यूबेशन। हमारे पास में वी हैव 3 डिफरेंट कैटेगरीज इनटू these particular innovators. जो सबसे पहले स्टूडेंट आते हैं with their ideas, we put them into the category of the innovators, जो अपने आइडिया पे काम करते हैं, रिसर्च जहां पे उनको और रिसर्च करने की जरूरत है to have the fullest product. So we used to term all these students as the innovators. Later on, if they are able to develop certain good prototype, then we used to put that particular student into the pre-incubation category. वहां पे वो अपने आइडिया को, प्रोटोटाइप को वैलिडेशन से लेके एमवीपी, दैट इज द मिनिमम वायबल प्रोडक्ट तक जब लेके आएगा अप टू द टीआरएल लेवल 8 and 9, then later on when he achieved the TRL level 9, we used to take him as the startup. And startup होने के बाद में we used to do his startup recognition from the Startup India portal as their DPIT recognition number. उसके बाद में he will be a recognized startup. सो ये जो साइकिल है, डेवलपमेंट साइकिल, जैसे आपको यहाँ पे दिख रहा है, आइडिया जनरेशन, मार्केट रिसर्च, प्रोटोटाइपिंग एंड टेस्टिंग, देन एमवीपी डेवलपमेंट, प्रोडक्ट लॉन्चिंग एंड पोस्ट लॉन्च रिव्यू फॉर द ग्रोथ, फॉर द नेटवर्क, वो जो चीज है दैट इज देयर. फिर ये सब करने के लिए उसको, उसका जो पर्टिकुलर प्रोडक्ट है उसको ए मार्केट एनालिसिस भी करना बहुत जरूरी है कि उसका जो प्रोडक्ट है उसका कितना मार्केट है, उसमें से वो कितना सर्व कर सकता है. सर्विसेबल अवेलेबल मार्केट, व्हाट वी यूज टू से इट एज द सैप, और टोटल मार्केट कितना अवेलेबल है उसके प्रोडक्ट के लिए, इट इज द टैम, दैट इज द टोटल एड्रेसेबल मार्केट. और वो कितना सर्व कर सकता है, दैट इज द सोम, दैट इज द सर्विसेबल ऑब्टेनेबल मार्केट. तो ये सभी रियलिटीज है. जैसे ही वो यहाँ पे आता है, वी यूज टू गाइड हिम रिगार्डिंग द पिचिंग ऑल्सो, सैम, सोम, टैम, द कंप्लीट मार्केट एनालिसिस, वेरी गुड पोजीशंस, जो कि बहुत वेरिड डोमेन के हैं, आप ही के सब्जेक्ट के हैं लेकिन वेरिड डोमेन्स के हैं. तो यू कैन टेक द हेल्प ऑफ दिस एल्यूमिनाई, कि जो कि आपके जो स्टूडेंट हैं उनको उनका रिसर्च कंप्लीट करने के लिए, प्रोडक्ट के जर्नी में, प्रोटोटाइप डेवलपमेंट के लिए आप लोग उनकी हेल्प ले सकते हैं. Corporate partners are there, industry partners are there, industry leaders are there, then the different investors are also there. You can tap all these different partners, the linkages, collaborators, so that your student will grow in that particular direction. So this is the thing, whether you are able to see the PPT or not.
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
जो टीआरएल लेवल मैंने बताए थे वो देखे आपने या नहीं देखे?
TRL वाली देखी.
and TRL levels.
That was visible.
था, वहां था.
Yes, sir. Okay. So TRL levels are very important. One must know. The faculty must aware about that. Therefore, then the different financial relief for the startups. हम अपने यहाँ पे इंक्यूबेशन सेंटर में क्या क्या उसको सपोर्ट कर रहे हैं, तो उसको ऑफिस स्पेस दे रहे हैं, डिफरेंट फैसिलिटीज जो चाहिए उसको, कंप्यूटर्स चाहिए, इंटरनेट चाहिए, बाकी के भी जो पेरिफेरल्स चाहिए, प्रेजेंटेशंस के लिए एक हॉल चाहिए, कॉन्फ्रेंस रूम चाहिए, मीटिंग हॉल चाहिए, ये सभी फैसिलिटीज जो है इंक्यूबेशन सेंटर उसको प्रोवाइड करता है along with the co-working space. Then एडमिनिस्ट्रेटिव सपोर्ट भी उसको चाहिए, उसको लीगल भी एडवाइस चाहिए, क्योंकि स्टूडेंट को लीगलिटीज मालूम नहीं होता है। जैसे आपने कहीं पे पढ़ा होगा कि स्टार्टअप का फेल्यूर का रेट भी बहुत ज्यादा है। तो क्यों है? वो टेक्निकली बहुत अच्छे हैं, उनको प्रोडक्ट भी डेवलप करना आता है, नेटवर्किंग के लिए भी वो बहुत स्ट्रगल कर रहे हैं, नेटवर्क भी वो टैप कर लेते हैं, लेकिन दे फेल इन अचीविंग ऑल द लीगल एस्पेक्ट जो कि उनको मैंडेटरी है। उनका हर साल का यूटिलाइजेशन, उनका हर साल का ऑडिट, ऑडिटर्स रिपोर्ट, एमसीए पोर्टल पे चढ़ाना, एमसीए पोर्टल क्या है वहां पे रजिस्ट्रेशन, ये जो लीगल एस्पेक्ट्स है ये उनको मालूम नहीं होते। दे आर लैगिंग, दे आर नॉट एबल टू हैव और हायर दिस पर्टिकुलर सर्विसेज, और वहां पे फेल्यूर होते हैं। जैसे अगर हम यहाँ पे सर्विस कर रहे हैं, इनकम है तो हमको इनकम टैक्स भरना कंपलसरी है, रिटर्न्स फाइल करना कंपलसरी है। अगर हम करते नहीं, हमारे जो सेविंग्स है, तो हमारे पे भी चार्जेस लगेंगे। तो ये जो बेसिक लीगलिटीज है वो कंप्लीट करना बहुत जरूरी है हर एक स्टार्टअप्स ने। अगर वो फेल होता है इन ऑल दिस कंप्लायंसेस, तो उनको नेचुरली लीगल नोटिसेस आएंगे, और वो जो लीगल पार्ट है अगर एक बार चालू हो गया तो ही नीड टू डू ऑल द कंप्लायंसेस। तो उसके पहले ही उसने क्या करना चाहिए, ये जो एडवाइस है, ये जो सपोर्ट है, ये इंक्यूबेशन सेंटर देता है। लीगल है, सेम वे द फाइनेंशियल ऑल्सो। फंड मिलना एक अलग चीज है, लेकिन वो फंड का प्रॉपर यूटिलाइजेशन, फॉर दैट पर्टिकुलर फंड देयर आर लॉट ऑफ लीगल डॉक्यूमेंट्स ही नीड टू साइन। जैसे उसके कंपनी के पूरे जो लीगल एस्पेक्ट्स है, उसका ड्यू डिलिजेंस है, वो पूरा ड्यू डिलिजेंस हम करवाते हैं थ्रू द ऑडिटर्स। तो एमसीए पोर्टल पे उसका मिरर है, रिफ्लेक्शन है, इमेज है उसकी। थ्रू दैट वो कंपनी कैसी है, क्या काम करी है, उसके पूरे कंप्लायंसेस हुए हैं नहीं हुए हैं, वन कैन टैप ऑल दिस थिंग्स। तो उसका वो जो कंप्लायंसेस है करना बहुत जरूरी है। ये जो सर्विसेज है ये स्टूडेंट्स को मालूम नहीं होते हैं, और इसी पर्टिकुलर ट्रैप में फंसता है स्टूडेंट। और प्रोडक्ट भले ही अच्छा होगा तो वो वहां पे आगे ग्रो नहीं कर पाता है। फिर उसमें जो इन्वेस्ट किए हुए लोगों ने पैसे है वो भी उसको यूटिलाइज नहीं कर सकता है, एंड ऑल द इन्वेस्टर दे आर ऑल्सो टेकिंग देयर मनी बैक, क्योंकि कंपनी ही सिंक हो रही है। सो इन दिस वे ग्रो होने के जगह पे वो फंसता जाता है, और कंपनी क्लोजर पे डालनी पड़ती है उसको। तो ये लीगल फाइनेंशियल एस्पेक्ट जो है वो बहुत ज्यादा जरूरी है, क्योंकि उसको फाइनेंशियल टर्म्स समझ में आनी चाहिए। स्ट्रक्चर, सपोर्ट, मेंटरिंग, नेटवर्किंग, बिजनेस मॉडल, दैट इज वन इम्पॉर्टेंट एस्पेक्ट। मेरा जो प्रोडक्ट है बहुत अच्छा है, लेकिन मुझे उसका बिजनेस प्लान भी देते आना चाहिए। जैसे जोमैटो स्विगी क्या करता है? दोज आर ओनली द फूड डिलीवरी बिजनेस। वो खुद फूड बना रहा है क्या? नहीं, दे आर जस्ट डिलीवरिंग द फूड फ्रॉम द होटल टू योर हाउस। फॉर दैट दे आर चार्जिंग 30 रुपीज। और human psychology also plays a very important role in every business, in every aspect. जहाँ पे भी आप कोई बिजनेस करना चाहते हैं तो ह्यूमन साइकोलॉजी स्टडी करना बहुत जरूरी है। तो आपने बहुत लोगों का देखा होगा कि जो पहले आपको फ्री देते हैं, फिर चार्जेस करते हैं, पूरा मार्केट कैप्चर कर लेते हैं। तो ह्यूमन टेंडेंसी है, जो फ्री का मिल रहा है मैं लेना चाहती हूँ, तो हम वो कस्टमर बनाते हैं। तो कस्टमर बनने के बाद में हमको वही चाहिए, फिर हम दूसरे ब्रांड के पास में नहीं जाते हैं, तो वो मेरा परमानेंट कस्टमर बन जाता है। तो ये जो बिजनेस टैक्टिक्स है, बिजनेस मॉडल्स है, जैसे हम डिस्कस कर रहे थे जोमेटो स्विगी, तो वो जो जोमेटो स्विगी है आपको घर पे फूड पार्सल लाके देता है, उसके लिए 30 रुपीज चार्ज करता है। और कस्टमर का भी साइकोलॉजी क्या है, मैं अगर फूड पार्सल लेने होटल जाती हूँ तो मुझे तैयार होना पड़ेगा, गाड़ी निकालना पड़ेगा, पेट्रोल खर्चा करना पड़ेगा, होटल में आधा घंटा वेट करना पड़ेगा, और मैं फूड पार्सल लेके आधे घंटे के बाद में घर पे आऊंगी। तो मैं अगर कुछ काम कर रही हूँ तो मेरे हाथ में का जो काम है वो छोड़ के आई नीड टू रश फॉर दैट पर्टिकुलर फूड पार्सल। इंस्टेड ऑफ दैट आई एम रेडी टू पे द 30 रुपीज। तो ये जो पर्टिकुलर बिजनेस मॉडल है ऑफ Zomato, Swiggy, it is of that 30 rupees. And from that 30 rupees, they become the multimillionaire. इतना पावरफुल है ये बिजनेस मॉडल। तो आपको आपका खुद का बिजनेस मॉडल सेट करते आना चाहिए, जो कि आपका प्रॉफिटेबल मार्जिन के साथ में ग्रो करेगा। दैट इज वन ऑफ द एग्जाम्पल आई वॉन्ट टू कोट। ऐसे बहुत लोगों के बहुत अलग अलग बिजनेस मॉडल है। One need to study that. We need to adopt one particular business model which is suitable for their businesses. इंक्यूबेशन सेंटर से उसको क्या क्या प्रोज एंड कॉन्स हो सकते हैं, पूरा सपोर्ट मिलेगा स्टार्टअप इकोसिस्टम का, उसको लैब्स मिलेंगे, मेंटर्स मिलेंगे, इनोवेशन का बूस्ट मिलेगा, आईपी का सपोर्ट मिलेगा, नेटवर्किंग मिलेगा, बैकिंग मिलेगा, लीगल मिलेगा, फाइनेंशियल मिलेगा, तो सक्सेस का ग्रोथ रहेगा उसका। तो अलॉन्ग विद दैट ही विल गेट द नेटवर्क उसको स्टार्टअप का भी मिलेगा, इंडस्ट्री का भी मिलेगा, कॉर्पोरेट सेक्टर का जो है गवर्नमेंट ऑफिशियल्स का भी मिलेगा, क्योंकि गवर्नमेंट के सभी डिपार्टमेंट्स आर ऑल्सो कनेक्टेड विद द इंक्यूबेशन सेंटर। गवर्नमेंट हैज लॉट ऑफ डिफरेंट डिपार्टमेंट्स, जैसे डीआईसी है, एमसीईडी है, माइम है, स्किल के मिनिस्ट्री है, एंटरप्रेन्योरशिप की मिनिस्ट्री है, ट्रेड का मिनिस्ट्री है। इन सब के साथ में इंक्यूबेटर का एक अच्छा कनेक्ट रहता है। तो इन सभी डिपार्टमेंट के ऑफिशियल से आपके प्रोजेक्ट प्रपोजल से वन कैन परस्यू दिस पर्टिकुलर प्रोजेक्ट प्रपोजल्स थ्रू द इंक्यूबेशन सेंटर। अल्टीमेटली you are able to reach to the larger, wider scope you will have, and ultimately the success rate and the probability of reaching to the large market, it increases. Now this we have seen that the incubation की process कैसी होंगी। One need to approach to the incubation center with the application. Then there will be domain specific experts along with the innovator, incubation expert and industry expert, कि वो आइडिया लेके आया है तो उसका इनोवेशन क्या है, उसका वैलिडेशन है, कुछ उसका इम्पैक्ट है, उसका पोटेंशियल क्या है, कितना आगे जाएगा। तो ये सभी एंगल से देखने वाले, जैसे इंक्यूबेशन वाले लोग देखेंगे, इंडस्ट्री वाले लोग देखेंगे, और उस डोमेन स्पेसिफिक experts भी देखेंगे। Once that particular scrutiny it has been done, then we used to register that particular fellow student as the pre-incubator. Once the pre-incubation period it is over, it will be vary from 6 to 8 months. In this particular pre-incubation period, he must be at the MVP level. उसका prototyping level validation होके minimum viable product तक वो आना चाहिए. वो होने के बाद में we used to register that particular student for his company into the incubation center as a startup. And then once he grow, we have decided the threshold value up to 1 CR. उसका टर्न ओवर अगर 1 CR तक होता है तो we will treat these startup as the graduated startup. Or within 3 years, if he has achieved few of the milestone, we can also graduate him, and those particular startup now they will be the graduated from our incubation center. So there are different stages through that we used to filter out and registered the startup in our incubation center. अब स्टार्टअप के साइड में भी उसको भी खुद का जर्नी डिसाइड करना बहुत जरूरी है. जैसे वो अपने खुद के आइडिया पे काम कर रहा है, आइडिया वैलिडेशन से लेके मार्केट रिसर्च, जैसे मैंने बीच में अलग स्लाइड बताई थी आपको मार्केट रिसर्च की, उसको मार्केट एनालिसिस भी करना है, जेन ह्यूमन साइकोलॉजी भी स्टडी करना है, टीम बिल्ड करना है, क्योंकि हर एक काम मैं अकेला नहीं कर सकता. क्योंकि मेरी एक्सपर्टीज अगर टेक्निकलिटी में है, मैं कंप्यूटर साइंस में एक्सपर्ट हूँ तो मैं टेक्निकल पर्सन हूँ. आई एम नॉट एक्सपर्ट ऑफ द फाइनेंस पार्ट, आई एम नॉट एक्सपर्ट ऑफ द बिजनेस पार्ट. तो मार्केटिंग मेरा फोटे नहीं है, फाइनेंस मेरा फोटे नहीं है, तो आई मस्ट हैव द टीम ऑफ 2 और मोर, जहाँ पे अगर एक पर्सन टेक्निकल है तो अनदर पर्सन मस्ट बी ऑफ मार्केटिंग. This is the best combination for the startup to grow their businesses. So later on, बाकी के जो services है, you can hire that services and you can establish yourself. तो business model establishment है, finances है, legal aspects है, ये सभी पे आपको काम करना है. और आपका जो टारगेट मार्केट कौन सा सेक्टर है, कितना परसेंट आपका मार्केट है, और उस पर्टिकुलर मार्केट में आप कितना सर्व कर सकते, कितना परसेंट आपकी कैपेसिटी है, आपका पोटेंशियल है टू सर्व दैट पर्टिकुलर प्रोडक्ट टू द कम्युनिटी. तो ये भी आपको देखना है थ्रू योर मार्केट एनालिसिस एंड थ्रू योर बिजनेस मॉडल. तो ये सभी चीजें स्टार्टअप को पूरी खुद को वर्कआउट करना है. और इस पर्टिकुलर स्टेजेस में अगर उसको कुछ सपोर्ट लगता है फॉर द मार्केट रिसर्च टू मार्केट रीच टू द टीम बिल्डिंग, ये सभी कुछ स्टार्टअप की जर्नी है. तो ये जो इंक्यूबेशन सपोर्ट आपको दिख रहा है, जैसे ये बायोलॉजिकल फॉर्म में हमने बताया है कि पहला जो अर्ली स्टेज है इट इज द आइडिया स्टेज. फिर जो नेक्स्ट स्टेज है तो इंक्यूबेशन पर्टिकुलर पार्ट है, जहां पे हम उसको सभी सपोर्ट देते हैं, एक्सेसिंग टू द डिफरेंट रिसोर्सेस, मेंटरशिप, कोवर्किंग स्पेस एंड ऑल द डिफरेंट फैसिलिटीज. Then through the mentorship, guidance, market analysis, they are able to grow. Later on, at the prototyping level, they need certain marketing opportunities, funding access, that also we used to support. And then once they achieve that MVP level at the product level, now they are ready to fly into the world. That is their growth stage. And for this growth stage also, the incubation center support them to fly. ग्रेजुएशन के बाद में भी जो उसका ग्रोथ है, जहाँ पे उसको यूनिकॉर्न के तरफ जाने वाली जो जर्नी है, उसमें भी इंक्यूबेशन सपोर्ट देता है. मार्केट रेडीनेस है, जर्नी टुवर्ड्स द मार्केट रेडीनेस. जैसे हमने ये जो जर्नी है अभी सिंपल लैंग्वेज में देखी थी, द आइडिएशन, वैलिडेशन, प्रोटोटाइपिंग, मार्केट एनालिसिस एंड ग्रोथ एंड द स्केलिंग. स्केलिंग के बाद में they are ready to fly into the market. बहुत कुछ है. Technology also plays a very important role in this complete startup journey. जो startup ecosystem है उसमें nowadays one must be a IT literate. Not only that, he must be proficient in that, because digitalization it is there and AI plays the very important role nowadays. Irrespective of any of the domain, आपका केमिस्ट्री हो या फिजिक्स हो, आपको AI टूल्स आना बहुत जरूरी है. नॉट ओनली AI टूल्स, आपको डेटा एनालिसिस भी करते आना चाहिए, जिसके बेसिस पे यू आर एबल टू टेक द प्रॉपर डिसीजन. बिग डेटा एंड बिग डेटा एनालिटिक्स, these are the part and parcel of each and every startup. जैसे आपको डिजिटलाइजेशन आना चाहिए, AI ML का भी आपको नॉलेज होना चाहिए, बिग डेटा एंड बिग डेटा एनालिटिक्स भी आना चाहिए, एंड ई कॉमर्स जो है आपका फाइनेंशियल पार्ट है, अलॉन्ग विद द डिफरेंट ई मार्केट प्लेटफॉर्म्स जो है, वहां पे रजिस्ट्रेशन से लेके आपकी विजिबिलिटी कैसी बढ़ानी है, डिजिटल मार्केटिंग कैसा करना है, ये सभी का नॉलेज होना बहुत जरूरी है. Therefore, technology plays the very important role in every startup journey. Likewise, there are few more different aspects where every startup need to work to become a successful entrepreneur. जैसे ट्रेंड आइडेंटिफिकेशन, परफॉर्मेंस मेजरमेंट, कस्टमर बिहेवियर, आपका टारगेट मार्केट, देन स्ट्रैटेजिक पिवोटिंग है, स्ट्रैटेजिक प्लानिंग है, मार्केटिंग ऑप्टिमाइजेशन है, और रिसोर्स एलोकेशन है, जहां पे ऑल दीज डिसीजंस यू आर एबल टू टेक बेस्ड ऑन द डेटा एनालिटिक्स. So इस हिसाब से this is the unending thing where I can give you the on and on things जो कि बहुत जरूरी है इंक्यूबेशन के पॉइंट ऑफ व्यू से. So I will take a pause here, and if you have any questions you can ask me. Are you able to hear me? If you have any questions, you can ask me so that we are able to conclude.
Madam, you told startup has to be registered somewhere in the government portal. Where it should be?
DPIT का जो स्टार्टअप इंडिया का पोर्टल है, वहां पे आपको रजिस्ट्रेशन करना पड़ेगा उसका.
Okay.
मुझे ऐसा लगता है कि आप सभी लोग फैकल्टी मेंबर्स हैं, अपने अपने रिस्पेक्टिव इंस्टीट्यूट में आपके पास में ईडी सेल होगा, ई सेल होगा, आईआईसी का सेल होगा, या प्री इंक्यूबेशन सेंटर होगा, या कहीं पे इंक्यूबेशन सेंटर भी होगा आपके यहाँ पे. तो आप लोगों का अगर कोई ज्यादा वहाँ पे इन्वॉल्वमेंट नहीं होगा, तो नाउ यू टेक द इनिशिएटिव, यू टेक इंटरेस्ट इन द इंक्यूबेशन सेंटर, और आपके स्टूडेंट के पास में जो कुछ भी आइडिया है, अगर आप कुछ अच्छे प्रोजेक्ट्स करते हैं, तो उस पर्टिकुलर प्रोजेक्ट का हम प्रोडक्ट के रूप पे कन्वर्ट कर सकते हैं क्या? यू जस्ट टेस्ट द पॉसिबिलिटी, एंड इफ इट इज एस, then you can take the help of your incubation center to develop your product. Incubation centers are meant to help you out to register your company up to the funding. और जैसे टीचर्स के भी साइड में हम हमारा जो रिसर्च है पेटेंट तक करते हैं, पेटेंट हमारा हो गया है, लेकिन वो पेटेंट के बाद में क्या, व्हाट नेक्स्ट? अगर मैं खुद होके प्रोडक्ट नहीं करना चाहती, तो मैं, मेरा जो रिसर्च है, मेरा जो पेटेंट है, आई कैन सेल दैट पर्टिकुलर पेटेंट टू द इंडस्ट्री through the technology transfer. You can have a good agreement with the industry, and that particular technology you can sell to the industry, और उसके अगेंस्ट में आपको पूरी रॉयल्टी मिलेगी उसकी। तो ये भी हम कर सकते हैं। अगर हम खुद होके प्रोडक्ट नहीं कर सकते, हम उतना टाइम नहीं दे सकते, तो हम टेक्नोलॉजी ट्रांसफर भी कर सकते। Any questions? If there are no questions, I'm very much thankful to the MMTTC that they have given me this opportunity to interact with all of you, and hope that you are able to get something from these lectures, and wish you all the best to have your entrepreneurial journey in your respective parent institution. Thank you. Thank you very much.
Thank you, ma'am.
Thank you, ma'am.
Thank you all.
Thank you, ma'am.
Thank you, ma'am.
If you have any chance to come to Amravati, you can join Incubation Center.
Hello.
Is there anyone from the MMTTC side?
Santosh sir is there?
Yes, sir. Yes, sir. I'm here. Hello. Am I audible?
Audible, sir.
Yes. Okay. Good afternoon, everyone. I'm Professor Santosh Rao, Assistant Professor from Mission Mahavishwara Nanded. And, respected all, on behalf of all the participants, I express my sincere gratitude to Professor Swati Kelkar, Senior Professor, Department of Computer Science, Santa Gadi Baba, Amravati University, for our excellent session on role of incubator in academia. In this session, we talked about the incubation, some unicorn companies, then what is the role of incubator in startup, then technology readiness, and key stages, as well as the financial relief for startup. She also emphasized the importance of data analysis and e-commerce. Her insightful talk will strengthen the academic industry and it is highly interesting. We also thank the Malvi Mission Teacher Training Center, Santa Gadi Baba Amravati University, and UGC for arranging this valuable session. Special thanks to the technical team, as well as finally, thank you all the participants for your active participation. Thank you.
Hello. Hello, Pingre sir.
Hello.
Hello, sir. Namaskar.
Namaskar. Good afternoon.
Good afternoon, sir. So one more time, I welcome you, sir.
Yes.
Once again.
Thank you. Thank you.
Sir, shall we start with the session, sir?
Yes. I'm ready.
Okay, sir. Okay, sir. I request you and I hand over the session to you, sir. Please. You may, sir.
So shall I start directly?
Yes, sir. I think all the participants they already know you.
Yes.
And as a physical chemistry and computational chemistry expertise that you are having, we are really very grateful to you, sir, that you have given.
Thank you. I hope participants are enjoying it.
Yeah, one more time they are having a chance to understand this computational chemistry. I think very few people will talk about this.
Yes.
You all are eagerly waiting for that, sir. May I request you now to start the session, please?
Yeah. Okay, madam. Thank you. So let me share my screen. So good afternoon, everybody. So can you see my screen now?
Yes, sir.
Yes, sir. Okay. Thank you. So I will just pop up my slides. Yeah. Okay. So yesterday we have seen about computational chemistry, on what it is based on and how it is functioning, um, and then what information we are getting from the computational study. So I'm just recapping for a few minutes just what we have seen in quick this one, that because of faster computers and what we can say, uh, good algorithms, faster computer, and developed quantum chemistry knowledge, uh, we can use computers to study chemistry. So what we have seen, what is computational chemistry, how one atom is, we can see that one atom is interacting with another one in a molecule, or atom is interacting in other atoms in molecule, and how it is useful. Okay, so what we have seen there specifically, I will not go this one again, yeah, because as we have seen that not only computational chemistry or experiment, we have to go together for further research in chemistry, or to understand chemistry, chemical aspects. Yeah. Um, Yeah, we have also seen limitations, but now computers are very fast, so we can overcome, and also algorithms, programs. We are having very good programs like Gaussian and other programs, which I shown you, Amber, Cham, or other also programs are there. So this I'm saying for ab initio calculations from scratch. That also we have seen last time. What is ab initio? So algorithms we have seen are quite and programs are maturing, and so we can calculate various things. So basically we will see how we can use computational chemistry to understand chemistry, so that based on these properties and all. So I will not go into detail about theory. So but what we have seen, that because of motion, faster motion of electron than nuclei, uh, we can separate these motions by using Born-Oppenheimer approximation, and then we can calculate for each coordinate or for each spatial arrangement of atoms in molecule, we can calculate the energy of that system. For that, we have used this Hamiltonian, and then we can use variational method or perturbation theory for it, and then we can get such type of potential energy surface. So for our case, this potential energy surface, this minimum is important because for that geometrical parameters, that molecule is more stable or the system is more stable. So this uh, this potential energy surface is very important for us, and also by solving this we have seen what how we are taking wave functions for the calculations as lateral determinant wave function. We can choose which is antisymmetric and obeying Pauli exclusion principle. So then I will skip now this one, which we have seen yesterday, and we can use either Hartree-Fock theory or perturbation theory, this molar preset perturbation theory, or if we have good computational power, then we can go also for CI calculations for this. So we have also seen density functional theory, how in very brief, then the atomic orbitals, how we can construct to take that one. Also, we have seen what is the basis set to which are representing atomic orbitals, and then we can take those atomic orbitals for calculation. Then we have seen molecular orbital theory and this molecular orbital energy level diagram. So what we are having now, we are having each molecular orbital. See, we have also plotted these molecular orbitals. You can see the plots of here, plots of this. So these are the equations, molecular orbital orbitals, and also we are having energies. So we can use this for further study. Okay, so last time we have seen that although we don't know, it is especially for experimentalists, like other spectroscopic technique, we are using them to use in our research. Like that also we can use computational chemistry to explain the experimental findings, or also computational chemistry is guiding to for experiments, certain experiments, so we can do something like based on that, as I told you, a drug designing problem which we discussed yesterday. So, yeah, this complexity. So, based on the size of the system, we have to use proper method for that, like force field methods, molecular mechanics methods, two semi-empirical, then ab initio, Hartree-Fock or MP2 molar preset, and then couple cluster CI. We can use those expensive methods, but only for limited number of atoms. Okay, so these biomolecular systems I gave just example, and then molecular docking. We have seen this how it is beneficial. This is a recent example how computational chemistry helped to design a novel drug. This is Galnavax. Actually, I haven't told last time name of the drug, and which is in the market now. So yeah, I request all participant, please mute their this one devices. Okay, so now coming to very exciting area. Okay, thank you, Payal. Okay, so now coming to very exciting area, that is molecular electronics. See, molecular electronics, like our electronic devices, can we use molecules as electronic device, because Professor McDermott shown that he got Nobel Prize for conducting polymers, and so we can use molecules as wires or some other devices. So these devices are ready now, and what is the next target is to we have to make these what we can say these parts of these devices, we have to assemble them and we have to make them in function. So this is just example C, molecule, smallest bit of substance that retain its chemical properties, yes. And then this molecule as a functional circuits in 2001, as I told you that, and also wire switches and memories. They are they are showing the properties of these wires as well as switches and memory motors. So earlier, if you see the okay, let's take diodes or diodes in our computer, the device which we are using, let's say laptop or desktop. Earlier, if you see the old computer, that was very big, a big, maybe we can say hall like that. But now computers are much smaller, like our laptops and mobile phones. So now this, can we go further smaller in size? Can we make these computers more smaller? As we know that if we make a smaller device, then we will need less energy. So that is so that earlier people used to do top-down approach, make particular device size of that particular device smaller and smaller and smaller and smaller. But at the what we now thing is happening that in diodes people we are using silicon or chips for that for these diodes. And what is happening, this silicon, when we take below certain size, it will lose its band gap property. So now how can we go further? So it's another approach which is called as bottom up approach, that we can take molecules, which is the smallest part, having the chemical properties, certain chemical property. So we can construct these assemble, or we can construct these devices. We can add into molecules and grow the device as per our need. So that is a from molecule to bigger molecular system. We can so people are trying to now take that approach, because then that is another way which can we can make our devices molecular devices smaller. So example is you can see the natural nano device as ant's brain consumes this milliwatt of energy, capable of performing tasks. As we know that how ants are, no, ants are very clever, and how they are constructing their houses and that the house and see this. So they are very clever. Now, but ants' brain is a molecule. So molecule can work as an electronic device. That is a natural nano device. And if we see the molecular switch, let's say one molecular switch, and having a molecular weight of 450 gram, that means that is having 6 into, let's say that is a we can use a diode, one particular diode that is having a molecular weight 450 gram. So in that 1 mole of substance, we are having 6 into 10 raised to 23, that is Avogadro's number of molecules. And so number get, and this number of what we can say transistors, if we see in our laptop or whole in our city or in our state or whole world, that diodes number is much lesser than this. So we can imagine that what will be the future of this further electronic devices. So, miniature, when we make devices smaller, then they will be very fast, less power consuming, and cheaper electronic devices. As we know that, if we want to, yeah, I'll come to that point a little bit. Yeah, just see here now these wheels, these are molecular wheels. So we can, the wheels are ready. So can we use them? This is another example here that these gold electrodes connected, a molecule is connected to this gold electrode, and people have measured how much conductivity is how much that molecule is giving the conductivity. So at molecular level, I will give the example of that also. Here is another example, which is molecular switch. So this is a big molecule, and this ring, with certain, what we can say, condition, this ring will be at this place, and maybe let's say this is on condition, and when it will to at this position, then that is off. So we can design molecule like, so it will switch between two, what we can say, places, molecular switch. See here now, this is a wheelbarrow. We can see a like wheelbarrow, molecular wheelbarrow. So this we can, so this is to see the imagination, and we can see actually it's a motion by STM tip. So this is a paper is in 2009, Accounts of Chemical Research, very nice paper. And here we can see that nano trucks, like Fullerene wheels are there, and then chassis is there, and we can see the synthesis. How can we synthesis these nano trucks? That synthesis design is also there. So now thing is that how we can move these trucks, and what will be the use of such movement where we can apply this. So this is another area. See, this is a nano car. You can see also nano cars. Then, yeah, this is nano car, same designing. Then, how can we move, as I told? So this is, let's say, molecular nano car or something, and it has some cis and trans, some structure. So with light, we can convert cis trans, as like in bacterorhodopsin. With light, cis trans conversion is there, and because of that, proton is getting transferred from one side to another side of the cell membrane. So that is a proton pump based on light photons. So like that, can we use these photons, and then can we move these nano devices, nano cars or something. So this is just a when light will come, then with the cis to trans, and then it will go further, it will trans. This is another paper which I want to show, a single molecule potentiometer. See, it's in Nano Letter 2011. See, long back, this one is experimental actually. This one, that two gold electrodes are there, and in between they have connected a molecule, and for that we can, so we can use the resistance and conductance of such molecules. Okay, so this is the paper from US. Then here is another one by Venkatraman et al. Is a Nature paper in 2006. That again gold electrodes connected with X. That X entity is here. You can see now biphenyl and substituted biphenyl. Based on these substitutions, that dihedral angle between these two rings, phenyl rings, that is changing from 0, 17 to 88 and 90, like that. So when we change that, the conjugation of these two rings will change, and because of that conjugation, as conjugation will help to conduct more. So what they have observed, that conductance is as dihedral angle between two phenyl ring will increase, the conductance is going down, with calculated also and measured also. Okay, so experimental also. So they have done both experiment and, so see now where we are. Actually, we can measure conductance of a single molecule by gold electrode, and these electrodes are also in atomic form. Okay, so there is very interesting this one topic. So now thing is that these molecules, another example, if I is there, suppose we constructed a molecular robot. Molecular robot, as we know that the diameter of a human hair, normal human hair, is what we can say 50 50,000 nanometer roughly. And even the injection which we are taking for maybe vaccination or something, the diameter of that injection needle is much higher than our hair's diameter, but we can take that injection needle not very pleasantly, but we can take injection for our health purpose, and very easily we can take injection nowadays. So see, suppose a molecule having, if you take a benzene molecule, then roughly it's a 0.5, see, it's a size 0.5 nanometer. Then you, let's say that molecular robot is 50 nanometer. So 50 nanometer and 50,000 nanometer. So if we compare the size, our hair size, diameter size is much more than the molecular robot, which is having 50 nanometer. So we can take very easily in our body, and then if we make it as a functioning, so we can break bonds and form bonds inside our body. Suppose there is a hard blockage, then we can go send the robot there, and it can do the removal. It can remove the blockage. See, so such kind of things will be possible if we make this such kind of nano devices. Now we have to make them functioning. How can we make them functioning? So it's see, suppose the vehicle is there, then that engineer will use uh, his or her tools to repair, to put a wheel, or to repair a body, like that. Okay, but now for molecules actually, we cannot do that. We cannot take a single molecule with spatula and see that and repair it, right? So what we have to do, we have to actually, there actually, I'm saying we chemists are really lucky that we are now engineers of these molecules. We can change molecules as per our need. We can do reactions, chemical reactions, and we can make the molecules which are useful for us. So okay, so now that is one thing. So so these computational chemistry theories, and this will help us so to actually understand the properties of these molecules, and how can we bring functionalities in them. So how can we understand that? We can understand by molecular properties. Okay, so these properties, also transition state reactions. See, these spectroscopic observables, this computational chemistry we can use. Also geometry prediction. Then benchmarks of parameterization, means we can set up particular parameters for particular thing. And also computational chemistry will help or directing to the experimentalist, or explain the experimental findings for that. Okay, so if we want to that molecular electronic devices which we have seen, to make them functional, or to understand chemistry also, how computational chemistry will use, so we have to understand with this. So let's go with these molecular properties, right? So first thing is geometry. As we have seen the potential energy surface last time, yesterday, and then see here it's a minimum, or in two-dimensional potential energy surface. There are also similarly three-dimensional for a 3D molecule. And how can we get this minimum? Very simple. So if this is a function, then first derivative of that function should be 0 with various parameters. This is a two-dimensional surface. So if three-dimensional, so we will get third dabba v by dabba R3 equal to 0. And to get a minimum, we have to take second derivative, and that derivative should be positive. So based on that, we can construct a second derivative matrix of that function, and which is called as a Hessian matrix. And when we diagonalize that Hessian matrix, so we will come to that whether that is minimum or maximum or saddle point. What is saddle point, that we will see. So yeah, here now we can see that a stationary point where the first derivative of that is equal to 0, and second derivative, when let's say for two-dimensional molecule, 2D molecule, both the second derivatives are positive. That means from both direction, that is a minimum. Now here, in case of saddle, see, first derivatives will be 0, both, and one derivative is positive and another one is negative. That means one direction, this is maximum in this direction, and another direction which is perpendicular, this is minimum. So we can say this such points as a saddle point. Okay, and here is an example of minima, maxima, where first derivatives are 0 and second derivatives are negative. Okay, so in 3D also, so we can find out a three-dimensional potential energy surface for this, and then we will get the structure in 3 dimension, which is more stable, having minimum energy. So that, as last time I explained the optimization process. So here now, see here, this is a this transition state is very important for the reaction. So here now we can see a reactant. It's a minimum. This is a potential energy surface. If we extend here now, so it's a potential energy surface for reactant, and this is potential energy surface for product. And then it will connect. This is one minimum and this is another minimum. Let's say this is a reactant and product. So this reaction will walk through a minimum energy path. Means minimum energy path means reaction will not go, will not climb through this mountain and go there. So it will take a minimum energy path, and the point which is maximum there, that is our transition state. Okay, so this transition state is important. So we will get the structure of transition state. We can characterize. So these points called minimum, then saddle point, maximum, these are called as critical point. Okay, so these are critical points of the potential energy surface which we are talking. So as we know that the distance between this is a reactant, minimum reactant, and maximum, which is transition state, distance between this is activation energy. So we can calculate activation energy, that is difference between this and this level of energy. And as we know that if I know activation energy, then we can study kinetics of the system. Further, this is a reactant minimum and product minimum. Difference between that, we can say this is enthalpy, and if we know enthalpy, then we can study thermodynamic properties also. So see, with computational chemistry, we can study kinetics, we can study thermodynamical properties. I'm just giving basic simple examples, so we will be especially our experimental friends, they will get idea about really how these computational chemistry people, they are doing calculations on computer, how they are studying chemistry. Okay, so as this is very famous, okay, then reaction energies, which just now we explained, enthalpies we can calculate, activation energies we can do, kinetics and all this. Another thing is that for, let's say I'm taking two examples, one example, that is one what we can say form of cyclohexane is chair form, very simple example, and another one is boat form. So If we do a potential energy surface calculation, and at the minimum, this is the energy for cyclohexane chair form, and this is the energy for cyclohexane boat form. Okay, as we know that lower energy means more stable structure. So we can see here minus 235.89 and here minus 235.88. So this one is lower energy, and that means that's why this is more stable. So see, instead of just saying what type of interactions are there, 1,4 axial interactions or whatever kind to x, instead of that, if we calculate the energies, then we can show that which conformations, which configuration is more stable in a system, and then we can compare with our experiments why particular system is more stable than other. Like that, we can support. Then, yeah, so here now we can see that reactants and transition state and product. So activation energy calculation for forward reaction, reverse reaction, we can calculate this one. A simple example where cycloaddition of ethylene to butadiene. Another property which we can calculate is dipole moment. And dipole moment equation is something like charge into distance between two poles. This is dipole moment. And this one we can write as we got the equation for molecular orbitals. So we can use these molecular orbitals and put a put a operator of dipole moment here, and then with this equation we can calculate. Finally, this, see, when we more simplify this phi r and phi star r and phi s, these are atomic orbitals, or we can say basis set forms, and then we can substitute that of optimized minimum energy structures, molecular orbitals, and then we can calculate dipole moment. See, here we have calculated dipole moment for water as a 2.042 with some basis set, some level of theory, and for benzene we can see 0. So as we know that dipole moment is very important for in chemical reaction, so we can calculate dipole moment. Then similarly, we can calculate frequencies, as frequencies are vibrational frequencies, IR frequencies. So these are very important in spectroscopy. So again, we can calculate this. So energy is, this is simple harmonic motion, energy is K by 2, Q minus Q equilibrium square. And then this is force constant. And then we can calculate K by taking second derivative of energy. And then that K, we know that frequency is related to K, 1 by 2 pi square root of K by mu. Also, we can calculate intensity, IR intensities based on mu, this equation. So we are having intensities, we are having frequencies, so we will get the IR spectrum of particular system. See, this is example for harmonic frequencies calculated with a certain level of theory. These are HF, Hartree-Fock, MP2, then high level calculation, CCSD, singles and doubles, couple cluster theory, like that. And we can see very nicely, these are three frequencies, vibrational frequencies for water, and see they are experimental frequencies are these one, and nicely matching with this. So computational chemistry will give quite reasonably nice frequencies. Then atomic charges and bond orders. As we know that atomic charges are very important, as in our organic chemistry, we have always used, let's say HF molecule, H is positive, F is negative, so delta plus charge, delta minus charge. So what are those deltas? We can calculate with computational chemistry calculations. This is electron density, and these are the what atomic charges and bond orders involve calculating the number of electrons belonging to an atom or shared between two atoms. So we can calculate that density, and based on that, we can calculate how many actually electrons they are belonging to atom A and how many are from belonging to atom B. We can calculate with certain space, and then we can compare with their atomic numbers. So as we know that in that atom, these many number of electrons are there, and the difference will be, we can calculate, and from that we can say that plus charge or minus charge. So I will not go much detail, but these are the molecular orbitals, and these are the each molecular orbital. This is a atomic orbital, phi 1, phi 2, phi 3, and phi m. So m atomic orbitals, we are taking linear combination to form a first molecular orbital. Then another set of coefficients, and where we are keeping the atomic orbitals fixed. This is another molecular orbital, and like that m molecular orbitals. So this is a normalization condition, and based on that, we can write this equation where S is the overlap integral. We can take integral, we can write this, let's say this psi 1 molecular orbital, and then another one psi star psi is a mod psi square. So we can write this one. Based on that, we can calculate actually how many, how much, or how many number of, what is the part of that electron is um uh, uh, there with that particular atom. So we can add up with all molecular orbitals and atomic orbitals, they are belonging to certain atom. So we will come to we can calculate that one. And also we can calculate the overlap between two atoms with these equations. I will not go much in much detail, but you can read. This is called as Mulliken population analysis. So number of electrons belongs to a number of electrons belong to atom A. We can calculate from all the atomic orbitals belonging to atom A. So we can calculate the charge by atomic number minus those many number of electrons. Similarly, we can also calculate the overlap between two nuclei. So we will get the bond order. So this is the example of, see here now. Oh, okay. Water molecule. If we calculate the charges, we can see that actually oxygen is having minus 0.61 charge, and hydrogen 0.31 and 0.31. So roughly, so there will be some numbers. So this is minus and this is plus. But you can see now when a water dimer will interact, this is a more stable structure of water dimer. And we can see that after in the optimized structure, what is happening actually, charge on this hydrogen, which was 0.31 more positive than this one, that means this is a little bit negative than the hydrogen in single water molecule. And see why that is happening, because there is a lone pair on this oxygen, and that lone pair electrons this hydrogen is taking to form this bond. Here is a bond order, which this 0.90 we can calculate. I have shown you how to calculate that. And here we can see that minus 0.66 and here minus 0.61. That means this is more negative. That means it has taken electrons from this one to for this interaction. So we can see what type of, like a charge transfer from one water molecule to other water molecule. Like that we can see the chemical reaction, what is happening in that particular binding of molecules. Then this is another property which is rho of r, that is mod psi square. That means mod psi is a wave function, and then we can, which is we have calculated optimized for a minimum energy structure, and then we can take This one mod psi square, and we can write the formula for that. And then we can do a critical point calculation. We have discussed critical point. What is critical point? Those are where first derivative is 0 and second derivative either will be positive or negative. Based on that, we can say that whether it is a minimum or saddle point or a maximum. So based on the Hessian matrix, we can further characterize these critical points with a I will go back for to show that a Hessian matrix. Please allow me. Yeah, let's say this is 3 by 3 and we diagonalize this Hessian matrix. Then if one direction it is a minimum, this is so this second derivative should be positive, this should be positive, this should be positive. So all the signs of these will be positive. Okay, so if we can write how many signs are there, so 3, so it's a +3 sign. And this is 3 by 3, so 3 plus 3 is a characterization of 3 plus 3 is characterization of a minimum. Okay, similarly 3 minus 3 is we can characterize as a maximum. That means for 3 directions, those are maxima. And saddle point, we can say that some of them are positive, some of them are negative. So based on that, depending on that, we can we can say saddle point. So here now I'm coming back to our density. We can define 3 minus 3 local minimum, then 3 minus 1 and 3 plus 1 saddle points, where here two directions they are maximum and one direction minimum. So total addition is +1. Here total addition is -3. Here total addition is +3 for minimum. Okay, local minimum on 3-dimensional surface. Here 3 plus 1, very similar like this, but 2 directions plus charge. Hessian matrix, not charge, it's a sign. So plus sign means it's a what we can say minimum. So 2 direction minimum, y direction maximum. So that is a saddle point. So based on that, they better developed this AMI theory. Okay, atoms in molecules. So we can see that actually these are the critical points for density critical points. And this is a water dimer. So we can see that this density critical point having a value 0.36449 atomic unit. Okay, so this is 0.36, and here there is a one critical point we will get, which is a saddle point. Okay, this is a saddle point, this is also saddle point, but its value is 0.024, much lesser than this. So this is a covalent bond we can see, and there is a bond because this critical point is present there. So, but that is a weak bond, or we can say that as a hydrogen bond. Very similarly for ammonia and water, we can see a hydrogen bond features there. So we can, through this property, we can say that whether these molecules are interacting with each other or not. If there are signs of these critical points, then we can say these are actually interacting. Then another property, molecular electrostatic potential. This is V of R. Again, here we have used rho. And what is rho? Rho is electron density, and that is mod psi square. So psi we have used to calculate V of R. What is V of R? Is a molecular electrostatic potential. Let's say we are having a water molecule, and then when we bring a unit positive charge to in the vicinity of this molecule, then what will happen? That is a work done to bring that unit positive charge. So a unit positive charge, when it will come closer to water, then what will happen? Water's nuclei as well as electrons will interact. And those interactions we have calculated separately here in this. So this is a nuclear interaction. We have given here positive sign, and electronic interaction, rho means electronic interaction, negative sign. So if electronic contribution or electrons are more at that point than nuclear contribution, then what will happen? That means value of this will be negative. So wherever the negative value, we can say that at that point, more electrons are localized at that place. If the value is negative, if it is positive, then it's a nuclear what we can say, part is more. Similarly, we can do again calculation of what we can say topographical. This is called as topographical analysis to identify the critical points, either minimum or maximum or saddle point. See, this is again a Hessian matrix. Here we can see this. Here a matrix with, this is Hessian matrix element, second derivative with respect to those coordinates. First derivative is equal to 0. Okay. So now let's see some example. Yeah, then we can calculate 3 minus 1 critical point low. So again, we can identify the lone pairs, where lone pairs are, because at lone pair, it should be more negative. So electron should be more there. So we can actually use this property to identify electron localization and maybe to get the interaction of molecules based on that, like lock and key interactions. See here, very interesting, water molecule having this is isosurface of molecular electrostatic potential of value minus 0.087. And this is a critical point. What is critical point? It's a minimum. That means at this point, electrons are more localized. And value of that is here point minus 0.09. Okay. But other places we cannot see negative part. So positive part is that which I have not plotted. So we can see now these two lone pairs, rabbit here. So very beautifully we can see the lone pairs of particular molecule. Here if we see the interaction of two water molecules, we can see that this 0.092 value will enhance at this place. 0.108 minus 0.108, and it will diminish from minus 0.092 to minus 0.068. And here we cannot see the critical point that is utilized to formation of that bond. So see now how nicely we can characterize the interaction between two molecules. This is very long back. I have studied this one in 1998. Actually, this is a crown ether, which we published that paper in Journal of Physical Chemistry A. Crown ether, and this crown ether 18C6. So these are 6 oxygens arranged here, and there are 6 minima which we can see. Just now we have seen the minima, this minimum. Okay, like that for crown ether oxygen. These are the minima. 3 are one direction, 3 are other pace of that. So now if I want to see a water, how water molecule will interact to this, it will catch 2 minima. Okay, because hydrogens are positive. These are the negative pockets. These are like a lighthouse where ship will go and bind. So like that I can put water molecule at that place. And then when we optimize it, we will get this structure. Okay, not W2, another. So what is that? If this structure is there, then if we calculate the molecular electrostatic potential, we can see the negative part here and here. Actually, now it's not there where it has connected. Okay, so to the other side. So from where second water molecule will come, hydrogen at this place and another hydrogen where the other oxygens lone pair is there. Similarly, now when we calculate the molecular potential, it's something like this, and I have put OW3 there because there are 2 lone pairs, two what we can say negative pockets from this side, because this side now there is no negative pocket for crown ether. So I cannot put third water molecule here. So this is third one. And similarly, I can put fourth one here. Now all are blocked. So what is happening? This is another one. This is one crown ether, 4 water molecules, and this is another one. So when they will come closer, so see now this is weak interacted. So what will happen? This will break the bond and it will connect to other oxygen like this. So this is a stepwise hydration process for crown ether which we have shown there. And this structure is very, very exactly what we can say the same structure as crystal structure of 18 crown 6 with 4 water molecules. In conductant polymer, so what I am doing, I am also giving little idea about the research which my group is doing with computational chemistry. And that also now I will try to focus the earlier part which we have shown, you have seen. Okay. Then as we know that conjugated systems, there will be delocalization of electrons and charge mobility. That's what Professor McDermid, he has seen he has shown conducting polymers. Okay, so if we want to design a new material, then we have to understand the conduction and optical process mechanism. So pi, if we enhance pi overlap, then definitely it will increase the conductivity, which we have seen also in that Nature paper by Lata Venkatraman in 2006 experimental study. Biphenyl dihedral angle, it rotated, and the conductivity which they have observed as decreasing with increasing dihedral angle between two phenyl groups. See now here which I have published actually in PCCP, Physical Chemistry, Chemical Physics Journal in 2011. See ethylene molecule, if we calculate the electrostatic potential values, we can see the minima here. That means electrons are local. So very nicely we can see the pi bond of ethylene. And when we connect these pi bonds, when we connect two ethylene together, that is like a butadiene. Okay, so what will happen now? This we can see very nicely one pi bond here, another pi bond here, but this is a saddle point where there is no pi bond. Okay, it's a what we can say alternate pi bond, and the value of this minimum is minus 16.04. Okay, and here some unit that is mostly kilocalories per mole. And here the conjugation, we can see this minimum and this minimum, they are connecting through this point, which I am saying, I said this as a conjugation critical point. So I can see a conjugation in butadiene. This is also another example. We can see a benzene molecule, and very nicely we can see the pi delocalization ring above and below with these critical points, minima and saddle. They are forming, and also all are same. So it's what we can say a structure, Kekulé structure, that if we see from this, we can see a ring, phenyl ring, and a circle inside when we see from the top side or bottom side. When we connect 2 biphenyl, we can also see the conjugation. So that value, conjugation CP value, I have shown in this paper that it will give me the amount of conjugation, intensity of conjugation between two units. Here also another furan, bifuran, which are conducting polymer units. So we can use that. See here this paper JCP in 2007, what they have done, they have actually demonstrated that continuous pi conjugation, okay, in this case conductivity is more, transmission coefficient is more, but they have broken the conjugation here. So we can see the also broken conjugation with molecular electrostatic potential map. See, suppose I want to design a system with three, what we can say, sides, and through which side there will be more conduction, how electron will conduct more. So see, we can see the conjugation, intensity of conjugation, and then we can assemble such kind of maybe routes or passing electron. This is another example where we have taken butadiene and connected R in this is in a book chapter, Electroactive Polymer, Macmillan publisher in 2011. So what is that? These all are various substituents groups which are electron NH2 electron donating, OCH3 electron donating, OHCH3 electron donating, and these are electron withdrawing. So what we have written that and observed the effect of on the that conjugation critical point or conjugation. And what we got there also we are having the substituent effect. We have seen that one as like Hammett equation. Okay, what is Hammett equation? Donating we know that Hammett equation log of K may be rate or equilibrium constant of when the molecule is having that particular substituent, and rate or equilibrium constant when molecule is not having that substituent. So difference we can see. So we can write the log of K x, where x is a substituent, equal to log of K0 no substituent, okay, minus a sigma rho. So sigma is what we can say reaction constant, and rho sorry, sigma is Hammett constant and rho is reaction constant. So when sigma is negative, then that we can say that that atom is more electron donating, and when it is positive, it is electron accepting. So what we have done, we have taken butadiene and observed conjugation critical point. Here also we have connected chlorine and observed this value of conjugation critical point. Then here also similar thing by applying NO, NO connecting the NO group, and here NH2 group. We can see the this one value of that conjugation critical point. So if we arrange that one in table, change this delta V of conjugation critical point with and without substituent difference and the substituent constant. If we plot this, we can see very nicely a nice correlation between these two substituent constant value and delta Vs electrostatic potential critical point value, that conjugation critical. And we can see that it is separating very nicely electron donating and electron withdrawing groups with proper integration. That means Cn is more electron withdrawing than OCN, then Cl, then CCH, then F. Here also CH3, then OCH3, then NH2. Here OH is here somewhere. So it will give me idea about substituent effect, that is whether that substituent is electron donating or withdrawing. This is another actually what we can say paper which I published long back also in Journal of American Chemical Society. What we have observed that we have calculated the polarization corrected electrolyte, because these cations will polarize the molecule, and that's why we have calculated that. And what actually people have observed that when a metal atom will come to a saturated hydrocarbon, then at particular place it is breaking and forming the respective products. So why it is happening? For that purpose, I have done this with the binding energy of lithium metal ion plus, and then we can see that very nice correlation with the value of polarization corrected molecular electrostatic potential. Further, now recently, my group is working something like helping to the experimentalist. This is one paper which we have published, experimental theory work together, rationally designed fluorocarbazoles as a multifunctional aggregation, induced emissive, emissive luminogen for the sensing of trinitrophenol, TNT, and cell imaging. So this is one paper with Dr. Atul Chaskar from ICT Mumbai. Then this is what we have, how we have given support with computational chemistry, what type of transitions are present, whether those are from pi to pi star, or those are from charge transfer, or those are N2 pi star. Like that, we can calculate homologue energies, and then these are the energies, and this will give the idea. And also another thing is that here see that molecules charge is at particular place, but other thing it's up to the other place. So we can also see the charge transfer in that particular system. From which part of the molecule charge transfer to from which part. This is another one. We have designed a synthesis and optoelectronic properties of novel donor acceptor base. This is related to blue, orange, fluorescent material. So that paper also very similarly we have done computational chemistry calculation and suggested some way, some new molecules or just explain their properties. Here also we have seen the transitions from lower molecular orbital to the higher molecular orbital, that we can see the gap between these two orbitals and we can explain. So I think this is roughly idea of there are many more areas where people are using computational chemistry. I have just focused on my particular group's topic, um, but in other areas also there are many, and especially for experimentalists, I hope with this background or idea, then maybe you can see in your system, in your research, where from where, in which part of my research I can take computational chemistry's help. So like that, we can move together in hands in hand. Okay, so I think I have to also give some time for questions or some discussion. So this is let me give the my group. Also, I'm having fundings from various funding agencies like ISRO, BSD, UP, DST, and this is my team. Um, Already this Eknath, then Anil, Yogita, Reshma, they have completed their PhD. Anuja just now given the Viva in last week. Pallavi also finished her PhD, and Surya has joined recently now. Pratik and other two members, Rohini and uh, Saurabh, they have joined in my group. So I think with this, I want to make my talk a little bit. I want to stop for to maybe discuss with you people. So thank you very much. And once again, I thank to the organizer for giving me this opportunity to interact with you and bringing the idea about computational chemistry, what computational chemistry can do. So this is very tip of the iceberg. Actually, people are working a lot like proton transfer mechanism, biomechanisms, or there are various systems to understand, mechanism, biomechanism, or why such kind of organic reaction is going, why other is not going, like that we can study with this. Okay, so if especially experimental participants, if you want to do some some experiment, you want some support from computational chemistry, or you have any doubt, maybe you can also contact me in future also. So this is my email address. You can write to me, or you can also you can write to me a mail for that. So thank you very much again. Uh, I'll be happy to again discuss with you on this. So thank you.
Thank you, sir. Thank you so much. Participant, if there are any questions, couple of questions we will take.
Yeah, I hope they will ask
Please ask.
something, especially experimental. So that's why I have just given some time for such discussion. So we can finish our talk within time. Yes.
Yes, anyone has any questions or the queries?
Sir, I have a question.
Yeah, please.
Sir, are these calculations in any way help the to study the progress of a chemical reaction?
Yes, chemical reaction in what sense?
Like I am synthesizing a new product.
Okay.
So, while it is going on,
Yeah, so while it is going,
progress of a chemical reaction, not final product.
not final
Whether we are
product, but
going in a right direction or
yeah, so
something like that.
if you are getting some intermediates or something, some intermediates, then you can actually calculate their spectroscopic this one and compare. So you will get in database what kind of product we are getting, or this one you can monitor um, such kind of thing.
Okay.
Yes.
Hello, sir.
Yes,
Sir, am
please.
I audible?
Yeah,
I
yeah.
just wanted to ask, what are the different softwares which can be used or utilized for this computational calculation? Softwares.
Yeah, softwares. Actually, software for ab initio calculations, little bit high level calculations, we can use Gaussian software. Long back, our department has or on this one, so for 15 lakh rupees. So cost softwares are very. So that Gaussian developed by Professor J. Popal, who got Nobel Prize for that. Okay. Then there are also some softwares for biosystems, as I told yesterday, Amber, Cham, and even with Gaussian, we can use QMMM kind of calculations. Then there are other softwares, GROMAX. Such kind of softwares are also there for molecular dynamics. We can use to see how, as earlier question was there, how system is evolving. We can do with the time what will happen for that system. How actually, when I was doing my postdoctorate in Japan, there Professor Omine with Professor Omine, and in 2000, and he published one paper that which was a nature cover page story, that water what we can say, caught in the act of from ice from water to ice, means how water is becoming from ice to water, it was not knowing. And so if we know the mechanism, there will be a lot of revolution in our freeze system and all other things. So he did, his group did molecular dynamic calculations and observed that how a water structure and ice structure and what is happening in between, that he has shown, observed that mechanism. So like that, we can study the things.
Thank you, sir.
Excuse me, sir.
Yeah, please.
Can we use the computational chemistry to solve the quantum entanglement?
Quantum entanglement. What is that? I have to see that first.
Oh,
So then definitely I will give you the reply. What is that? Can you give me a
yes,
brief idea about
because you
that?
have,
So,
you have shown some quantum mechanical solutions by using computational chemistry. That's why I'm asking.
okay, okay.
Single electron system,
Yes, single
hydrogen
electron
atom.
system. Yes, we can actually study that. Normally, this with my friends from physics, they are doing actually single electron transfer in a molecule with the electrodes and yes, what they are saying, single electron, yeah, such kind of system. So people are studying that one with siesta and other trans siesta softwares, ATK softwares.
Okay. Thank you, sir. Nice, very nice presentation, sir.
Thank you very
Excellent.
much. Thank you. Thank you. Still, we are having some time.
Okay.
Okay.
Hello.
So if
Hello.
hello, yes, please.
Yes, sir. Can you hear me, sir?
Yeah, I can.
Yes, sir. Can you kindly elaborate on what is actual perturbation theory means?
Yeah, I actually explained that way in very brief. Perturbation theory means what? Suppose, see, for many electron systems, we cannot solve Schrodinger equation exactly, right? Okay, so we cannot calculate, solve Schrodinger equation. We will not get the wave functions and energies for many electron system because electron repulsion part we cannot solve exactly. Okay, so what people are doing, they are suppose the unsolved, which our system, which is of our interest. Okay, they are dividing that system into two parts. One part is the exactly solvable system, which is closer to that, plus some remaining part that we are saying that as a perturbation to that. And then we can write a Hamiltonian, right, unsolved, which is our interest system H, which is equal to what we can say H0 Hamiltonian for unperturbed system plus lambda H dash, where H dash is a perturbation to that and lambda is a variation parameter. When lambda is equal to 0, that means the system, our system is exactly equal to unperturbed one, and when lambda is 1, that means our system is completely perturbed. So that lambda, they will vary and they will do the order of this, they will solve that Maclaurin series and then they will do the calculations and calculate the corrections to the energies for how much is the correction to the exactly solvable system and how much correction we have to add into that to get the system. If we add first order correction, we will get some reasonably information about that. If we add second order perturbation result, then we will get more accurate. Like that, as we increase perturbation, then our calculations will be more and more time consuming and costly. So in brief, perturbation theory is like this.
Thank you, sir.
In simple words, I can say this one.
Obviously, sir. Yes.
Yeah,
Thank you.
thank you.
Good
Sir,
afternoon,
I
sir.
have a sir, I have a one question.
Yeah, please.
In Gaussian software, which computational methods are available?
In
In Gaussian,
Gaussian software, it is so fantastic software for which they have given Nobel Prize. Okay, to
Yes.
Professor J. Popper's group. And we can do very high level calculations to even for a what we can say molecular mechanics level calculations or semi empirical level calculations, depending on which system we are installing that software. Suppose we are installing on supercomputer, we will do lot of big calculations. And if we install on our piece laptop or a desktop machine, we can do certain kind of calculations. So based on memory,
How
based
can
on, uh-huh.
How can we do molecular mechanics by using Gaussian?
Yeah, we
Just you
can
said.
do. We can do. We
How?
can. Yeah, we can do. Their facility is there. You can give in have that one, that extended Huckel theory, EHT, or PPP theory. We can use such kind of things. Okay.
So
And
Gaussian is, I
even
heard till today, I heard that Gaussian is built only for DFT and not for
no,
molecular mechanics. So it is quantum mechanical phenomena.
actually now this
So now you are
version.
giving me new
Yeah,
things.
now this version, you can see the QMMM calculation also. Means what? Quantum mechanical as well as molecular mechanics. So molecular mechanics we can do. You please see the Gaussian web page and you will get the idea there. It's there in the this version of
Okay.
Gaussian. You can do that.
Okay, sir, one question. Suppose we have our server, like computer, if we install that Gaussian on our computer by taking from someone else or the
Yes.
correct version, and if we want to publish the paper,
No, we cannot. We cannot do that.
so we cannot publish it, right?
Yeah, we cannot publish that.
So we need to purchase software
Yeah,
itself.
purchase software or do collaborative work with the people those are having that software so they can help.
Okay. So is there any service available India level or some like CDAC or something they will provide for that national
No,
competition something?
you have to contact various institutes to check nearby institute, or yeah, in CDAC also our supercomputer is there. So at various places in Bangalore also, in various places. So you
So we
can
can
contact
do
those scientists
calculation
and
at our level, our computer,
uh-huh.
and then we can acknowledge the CDAC. Then it is fine to publish.
No, you cannot install there because you will need a key. Without key, you cannot
Okay.
install that software on your system.
Okay.
Good afternoon, sir. Sir, wonderful presentation.
Yeah, thank you very much.
Sir, can we use this computational chemistry in designing reaction mechanism?
Yes, of course. That is actually main theme of the computational chemistry. So we can see, as I told, how reaction is going from one state to another state. We can see that one. We can see what type of products or how reaction is progressing. That also we can see. So let's say some example that there is some proton transfer from one place to another place. Okay, so we can do calculation for reactant product and we can also find out the transition state, what will be the activation energy means for that. We can do the reaction mechanism. Actually, I have studied long back with our organic chemistry collaborators from my department, this addition, cycloaddition reaction. And very nicely, we have supported that, how that reaction is a first order reaction and the result they are getting, why they are getting particular result and not other one. So we can do that one.
Good afternoon, sir.
Yes, good afternoon.
Sir, I am working on the surfactant system. By the time we got some unusual morphology of the surfactants, can we confirm it by the
Sorry.
simulation?
What type of system?
I am working on the surfactant system. And
Surfactant.
Surfactant system.
Surfactant, okay.
Okay, and we got some unusual morphology like flower-like aggregate.
Okay.
Flower-like aggregates.
Yes.
So can we confirm it by the MD simulation?
Yes, you can, but I don't have expertise in that, so I am not the proper person to ask such question. But as I I have given the example of at a place where I did my postdoctorate, where they have shown that how water structure from ice to liquid water that is formed. So like that, one can do that and we can see. But see, it's a very
Actually, only
huge calculations and really not that much easy to do.
actually I am targeting for the Journal of American Chemical Society. Only
Uh-huh.
this part is missing.
Okay.
That's why I'm asking.
Yeah. But I'm sorry, I'm not working. I'm working in ab initio, not the molecular dynamic simulation. So maybe some what we can say. You can talk with some person, maybe from ISC Bangalore or some big institutes where computational power is also very high, and they are doing molecular dynamic kind of calculations. Especially Professor Biman Bakshi from ISC Bangalore, you can go to his homepage. Definitely, you will get the details.
Please, what's his name, Professor?
Professor Biman Bakshi. Actually, I met him when he came to Japan. He is very nice person.
IISc Bangalore.
Yes.
He's from IISc Bangalore.
Yeah.
Because these aggregates are no one else has the reported such type of aggregate for the surfactant system.
Okay. So, but I hope you will get the connection to that and support to your experiments.
Thank you very much.
So I think my email address is there. So if you have any query or something, I will try to help my best, or maybe give some suggestion that may help. Okay, so I think I again thank to the organizers again, and I also thank to all you participants, because see, I was expecting like this interaction between us, and you really asked many questions, and I enjoyed with that. So thank you very much.
Sir, let me give the vote of thanks.
Yeah, please. Thank you.
Okay. Hello, greeting to everyone. As we come to the conclusion of this insightful and enriching talk, it is a very honor to deliver the vote of thanks on behalf of organizing committee and participants. I am Dr. M. Sarath Babu, working as an assistant professor in Kargi College, which is affiliated with University of Delhi. First and foremost, I extend our deepest gratitude to our UGC HRDC Malviya Mission Teacher Training Center, Santkaj Baba Amravati University, for organizing such a valuable teacher training program. A heartfelt thanks to our distinguished speaker, Professor Subhas Pinkal, for sharing your expertise and knowledge of computational chemistry and its applications. Your presentations and discussions have been incredibly informative and engaging, offering us a new perspective and ideas. To our dedicated organizing committee, Honorable Vice Chancellor Milind Bharat, Director Professor Muhammad Atik, and course coordinator Professor Manisha Kapoda, thank you for your tireless effort and meticulous planning. Your hard work behind the scenes has ensured the smooth execution of the refresher course. A special thanks to our participants and attend for your active engagement and enthusiasm. Your presence and contribution have enriched the discussions and made this event a collaborative and a success. To the technical support team, thank you for your ensuring that all our sessions run seamlessly and virtually. Your expertise and dedication are greatly appreciated. In conclusion, thank you all once again for your invaluable contribution and participation. You have made this refresher course a memorable and impact practice. Have a great afternoon. Thank you.
Thank you, everybody.
Thank you, sir.
Thank you.
Thank you. So I am now just leaving from this. Thank you once more.
Thank you, sir.
Okay, so participant, I think we should move for our next session. Our next expert is there, Dr. Sneha Vankar, madam. Hello, Dr. Sneha, ma'am. Hello, Dr. Sneha, madam.
Hello.
Madam, whether we are audible to you, ma'am?
Yes, sir, you are audible. Am I audible to you,
Yeah,
sir?
ma'am, very much clear, ma'am, very much clear.
Oh, okay, okay. Thank you, sir.
So,
Thank you, sir.
shall we go for the session, ma'am, if you could permit?
Yes, sir.
Yeah. So, good afternoon, friends. Now we are moving towards the last session of today's last session for this refresher course, and to conduct and enlighten and in this session, we have with us a very great and scholarly personality, Dr. Sneha Vankar, madam, from one of the affiliating non-agricultural university in the Maharashtra, that is Gondwana University, Gadchiroli. So first of all, ma'am, I extend my warm welcome on behalf of Sant Gadge Baba Amravati University, Malvi Mission Teacher Training Center, and all the learned participants, those who have gathered from the across country to this refresher course, and particular to this session. And now, first of all, may I request Dr. Prajapati sir to please introduce our guest in brief, and then we will start with the session. Yes, Dr. Prajapati ji, please.
Yes, sir, I am audible.
Yeah, sir, very clearly, please.
Okay, sir. First of all, very good noon, all of you, giving me an opportunity introduction speech. Myself, Dr. Sarju Prajapati, Assistant Professor, Department of Chemistry, State PT Arts and Science College, Godhra. On behalf of Malavya Mission Teacher Training Center, Sant Gadge Baba Amravati University, Course Coordinator, Dr. Manisha Kodape ma'am, Ankit sir, entire team, and my dear all participants. It is my great honor and pleasure to welcome our esteemed guest speaker, Dr. Sneha R. Vankar, Assistant Professor in the Postgraduate Teaching Department of Chemistry, Gondwana University, Gadchiroli, Bharat. Ma'am is dedicated academician and inspiring teacher known for her commitment to excellence in teaching and research. Ma'am have also more than 9 years of teaching experience in UG and PG department. She also completed postdoctoral fellow of the Science and Engineering Research Board National Postdoctoral Fellowship in 2017 to 2019. Ma'am has received many award prizes and certificates. Ma'am has published more than 16 research papers in various reputed and international journals, and more than 4 books, reports, and chapters in various international publications. So today, Sneha ma'am will deliver a lecture on the sustainability blind spot, redefining the research gap in green chemistry. Once again, thank you all of you. Over to you, ma'am.
Thank you, sir. Thank you so much, sir, for introducing me. Now, I would like to share my share. Sir, my presentation is visible to all?
Yes, ma'am, visible.
Yes, ma'am. Okay.
Yes, ma'am.
Okay, thank you so much. So I will be talking regarding the sustainable blind spot, redefining the research gap in the green chemistry. I know that this is your last session, and I think most of you have already gone through the various lectures from different fields related to chemistry. But this is a bit different talk I would like to deliver here. First of all, I would like to thank Sant Gadge Baba Amravati University for giving me this opportunity to share my thoughts apart from my core research. So that is the reason it gave me an opportunity to go further and search what type of research now we need to do, rather than performing the same traditional and conventional research work. Maybe some of you will not agree with my ideas or the ideas which has been generated by the environmental protection acts and all. But as a chemist, we need to go for the green methodologies and green products which are eco-friendly as well as user-friendly. So I would like to start my talk with this sustainable development. So what do you mean by sustainable development? I will not go into the details of 17 sustainable development goals which has been developed by UN with the help of 100 and more than 100 countries stakeholders. Hello. Okay. So sustainable development is actually for the global economic growth. It is basically for environmental protection. It is basically for social inclusion, where we think about that all the facilities, whether it is good health facilities or education, all must reach to the all the communities, all the people they are belonging to any region or any caste or any gender. They must get a aura of inclusiveness. So these sustainable development goals were developed in order to reach those good habits actually. So if you see the milestone of reaching towards the sustainable development goals, it was started since 1992. The first summit, named as Earth Summit, it was held at Brazil, and the agenda was to protect life and environment. In 2000, the summit was held in at headquarters, that is New York. The agenda was to eliminate poverty. Then eventually the third gathering that was held at South Africa with the aim of eradication of poverty as well as multilateral partnership. Then 2012, the Sustainable Development Goals, they came to an existence, and that idea was generated with the help of all the country members who participated at in this summit. Then in 2015, the actual agendas were set up so that by the year 2030, the sustainable goal developments will be achieved. So since we are into 2026, we are not at all aware that how many goals will be achieved till to 2020. But if we monitor our development, then the outcomes are like more than 1 billion people they were lifted over the poverty line, and the child mortality rate is being controlled, and the diseases like HIV and this infectious disease, they are being controlled because of the good performance that is shown by our by the healthcare facilities, the development of vaccinations and all. That is the better development we can mark when we see the outcomes. So now there are other certain goals we are supposed to reach, and as a chemistry student, we are supposed to think about how this chemistry, and that is green chemistry, can be involved in order to reach that level. So by means of green chemistry, when it is first formulated by Paul Anathas and John Warner, they have given 12 principles of green chemistry, and I think everybody is aware of these 12 green principles of green chemistry, so I don't need to explain these principles. But according to United States Environmental Agency, they are talking about green chemistry that deals with design of chemical products and processes that reduces and eliminate the use or the generation of hazardous substances. So United States environmental agencies, they are carefully monitoring the entire research what is taking place in their country. We are having very good report. I forget to mention here that reference, but you can go through that report. And in year 2022, they have just reviewed that what chemistry is doing for the betterment of their country. So it is very interesting article. We can go through it. You can go through it. So now, clumping both the ideas of green chemistry and sustainable goals, we have generated the new terms that is called as green and sustainable chemistry. So to understand these concepts, what United Nations Environment Program did, they have consulted 100 expert stakeholders to generate new 10 objectives. We are aware about 17 sustainable development goals, and we are aware about green chemistry. There are 12 principles present in the green chemistry. But now, how we can use these green chemistry principle in order to achieve sustainable development goal? For that, this United Nations Environment Program, they have generated again 10 new objectives. So these are the 10 new objectives, and the document is available where you can go through each and every objectives, but I will discuss here. That is the bit different part, and that is the interesting part. We need to understand and redefine our research progress, research approach, what we are doing right now, just to make number of papers, just to make good citation number, just to get good H index and I index. I'm very sorry to say that most of our researchers will not in line with my ideas, but I think we are supposed to do research which is actually solving the societal problems, which are actually solving the environmental issues. So for that, they have taken this United Nations Environment Program has taken these steps. Now it's a high time to rethink about our research approaches. So the first objective is minimizing chemical hazards. So these statements have been given by them only. So I can't change these wordings and all, but they have given very good line, that is beginning with design. So design of chemicals with minimized or no hazard properties for use in material products and production process. For this, I think you in the last lecture you have already gone through the entire session related to computational chemistry. So I have given here a link which will directly take you to the QSR toolbox. It's a software actually, and everybody knows about, those who are working with medicinal chemistry, they knows about what is QSR. So QSR stands for quantitative structural activity relationship. So prior to the synthesis, it is needed, if you are designing a molecule, rather than synthesizing lot number of derivatives, you can prepare these derivatives in the software. Then you can just see the quantitative relationships where we are using descriptors. We are having properties like log p values. We are having properties like ADME, that is absorption is there, absorption is there, distribution is there, excretion is there, toxicity is there, and metabolism of the drug is there. So prior to the synthesis, if you are using your good energy in thinking about the designing of drug which is genuinely going to give some biological activity, then this task is to be done smartly by the use of technology. So I have given you here an example of QSR toolbox. It's a free software available, and it is also having a database of more than 60,000 chemical compounds. So you can go through it, and then you can just see that whether your design compound is in line with already designed one, or it is already reported. So you have to do a very good review literature, because most of the compounds are like they are reported, and the new people, they are just changing the substituents and then synthesizing the compound, then sending it for the biological activity. So it takes times, and I know most of the colleges, they are not having that much facilities for characterization. They need to use their funds. So better you can go for smart work. You just need a laptop with good configuration, or a system with good configuration, with good memory, where you can perform this activity. And these basic activities you can get done with your MSc students as well. You don't need, you can work this as a dry lab work. You don't need any wet lab. So whatever student is studying at their paper, in their medicinal chemistry papers, they can have these things under the practical sessions as well. So when we are doing this refresher course, it means we need to develop some methodologies for the teaching. I know that basing that Bloom's taxonomy and all there, that I'm not going to discuss with you, but I think you need to have some ideas how you can engage your students. So in the then updates related to their subjects. So using software, and then use of software rather than synthesizing molecules which is prescribed in your syllabus, it is better to design new molecules with the aid of such softwares will be useful. After this, after studying QSR, then optimizing structures, we can go for molecular docking and molecular dynamics by using some softwares like Autodoc is there. It's a free software, but advanced softwares like Schrodinger, you can use it. That's a very good software and very user friendly. So if you have, if you design a very efficient molecule, then you can consult such agencies who will help you for doing some docking and molecular dynamic studies. And I also want to tell you one thing, that if you are having molecule which you have designed as a heterocyclic compound is there, it is novel in nature, crystal structure is there, there is no issue of the issue with purity, then you can say send that structure, optimized structure to IIT Delhi. IIT Delhi is giving molecular docking data. If you are submitting your structure and submitting your target molecule may be a DNA or RNA or enzyme or protein. If you are submitting those molecules with PDB IDs and your structure, they will give you the docking data. So this is a preliminary work. You can get it done with your students. So this toolbox is a very good software. Actually, you can just go through it. I've just given the website, the link for this website. So first objective is starting when you are starting with your research topic. That research topic needs vigorous literature review and ideas that should go till the last, so that your product will be useful for in any purpose, whether in therapeutics or in polymer or anything in any field. The second objective is that avoiding regrettable substitutions and alternative. So if you see this objective, these objectives take you towards the nature. You can ask questions to the nature and you can observe the nature, how the nature is behaving. Or for example, if you see a geek tree, it is having very strong holding capacity. So we need to find out the adhesive which are present in the root of that particular tree. Then if you see the behavior of ants, how they are maintaining their line, so that idea can be taken for development of traffic rules and all, and it has been taken as well. So if you go with this website, this is asknature.org website. Here you will see how the biological strategies, how the things which are already available in the nature can be used in development of technology. For example, I have also shared one link, that is a YouTube link. It is a short documentary that is related to the promise of biomimicry. So here is an example you can see on my screen, that two researchers, they got inspired by a plant. The name of that plant is Urticaria virgalis. It is also called as bladderwort. It is a carnivorous plant which traps and digests insects larvae. So they have used this idea for developing a device which can catches up the larva present in the wastewater. So how this plant work actually? This plant actually work in the presence of sunlight. During the process of photosynthesis, this sac that you can see here, this sac get open and the insect get trapped inside it. The enzymes digest these larvae and then it convert into the nutritional product. So this idea is very much useful. These two researchers use this idea and develop a solar-based device to kill the larva. The next example I would like to put here, that I would like specifically like to mention here, because this idea was taken by two Indians and they have generated a sewage treatment system where they are not using any electricity for treating water. So how they got this idea? In inside the stomach of the cow, there is a bacteria which can respire, and it can exist under the condition that is anaerobic condition. So by using this idea, they have cultured this bacteria and used this bacteria in the purification of sewage water. because in that particular sewage water there is a condition which is created as an anaerobic condition. So it was found that these bacteria are useful for the elimination of pollutant present in that water, that too without using any energy source. So nature is giving us some ideas. We need to just observe, because we are not though we are a student of chemistry, we have done our PhDs. Maybe some of you are continuing your PhD. Some of you are more experienced than me. I'm very young in this academics. So our aim is to see, while performing PhD, while doing PhD degree, our aim is to publish 2-3 papers, get our degree, and then we will seek job according to our choice. This is what priority as a student we need to. Yes, or everybody is having this priority, but when now we are having a good job, because that's why we are doing this refresher course, just to refresh our thinkings, just to refresh our observation, just to redesign our needs. We are not supposed to go with the traditional works which are doing since last 10 years or 50 10 years, or your guide is doing that work, then you are continuing that work. So it is very difficult to get published such work. It is very difficult to get patents over there as well. I am also not having patent, because now it's a time to develop certain device or methodologies, then only you can have a good patent, and that will be satisfying. Just getting patent in the name of synthesis methodology and all, I don't think that is very good. That is a satisfaction for any researcher. But if you are genuinely solving a societal problem, then that will be very fruitful. So nature is having lots of solution for us. Then just our idea is to get outside and stop working only in the lab, go outside and follow the multidisciplinary approach. We as a chemist, as a chemistry student, we can't reach to all the points. We need the help of zoologists, we need the help of biochemists, we need the help of engineers, in physicists, and everybody. So there must be discussion with all these people, and then just point out one problem, not 10 problems, just one problem, and see if there any solution is already present in the nature. Then take that idea. We need to take that idea, and probably we can convert that idea into a technology. The third objective which is set is that sustainable sourcing of resources and feedstock. So nowadays, or since the monitoring agencies, they are complaining about carbon dioxide. Of course, we know that carbon dioxide is a very important component that is responsible for greenhouse and then climate change and everything. But how, as a chemistry, we can just see that carbon dioxide is a chemical that can be used as a reactant, that can be used as an initial component for other things. So this carbon dioxide can be directly used for the preparation of solvent, for the preparation of beverages, and after conversion also it can be used for the formation of new compounds. Like this, if you go with chemical conversion, if carbon dioxide is combined with directly with H2, then it can be useful for the preparation of methanol. And if carbon dioxide is converted into carbon monoxide, and then it is combined with hydrogen gas, then we can follow this Fischer-Tropsch catalyst mechanism, where we are using this reactant as a reactant for converting them into fuels. So carbon dioxide is a pollutant, but as a chemist, as a chemistry student, we need to think what products we can make from carbon dioxide. I don't know regarding other university. Recently, what happened? Our dealer told us that methanol is now, it is not allowed to sell methanol. It is banned. But he has given us, so if we can do anything such type of methanol production at our level, since we have to use it very carefully, because it is also a very harmful carcinogenic product. So while using any chemicals, we need to take care of this MSDS or the data which is already available. So again I will say that whatever pollution is already has been created, now it's time to control. We can't stop, we can only control. So one of our student affiliated to our university, he has designed a device. That device can be used as a collector of soot, which can be attached to the diesel trucks. So what he did, he just used that device to collect soot from particular where this emission is coming out. And after collection of that entire soot, he purified that soot, segregated that soot according to the particle size, and then he used that particles with mixing with suitable solvent as a coating on the solar panels. So it has been found, it is at very preliminary stage, and it has been found that without any supply of, without in the presence of sunlight also in this room, that light was showing better luminescence after coating that solar panel with this soot. So nothing is I think like impurity. You can have that idea to convert this product into this waste into something good product. The fourth objective is that advancing sustainability of the production process. Now, selection of product, selection of reactants or selection of initial component is important to think as a chemistry student. Then, according to green chemistry, it has been recommended that you are supposed to use catalyst, because catalyst will leads to better yield. It will leads to it will reduce energy, and it will lesser time consumption is there. But we know that all the catalysts we are using, they are mostly metal catalysts. So metals, transition metals or lanthanides, these are the metals which are generally used for that on the basis of their chemical and physical properties. But now we can think about organocatalysts. So organocatalyst is, I know many of the reactions reactions are done with the help of L-proline. L-proline is a simple small amino acid molecule which is used as a catalyst. So the remarkable achievement you can see here in the with the aid of green chemistry, I would like to explain this. This is the recent work in 2017. It has been reported. See, one drug is there, that is calcitide. Calcitide is a drug which is used for the treatment of hyperparathyroidism. So this drug is recommended for this treatment. So Angan, this research co-workers, what they did, they have changed the methodology for the synthesis of this drug, and they have adopted new methodology, that is solid phase peptide synthesis. Nowadays, we are already aware that organic molecules and metal complexes, they are used as drugs. For example, cisplatin is anti-cancer drug, and most of the organic compound basically having heterocyclic rings, they are showing biological activities, and all the anti-cancers and cardiovascular drugs, every drug is having such organic compound, only organic compound. But since last 35 years, the development has been done in the field of peptide based drug synthesis. So peptide is nothing but it's a small fragment of amino acid. The desired amino acids can be used to prepare drug. The best part of these amino acid based drugs is that it is having good potency, and these drugs are reaching towards the target, because targeted drugs, target based drugs are the always there will be challenge for the pharmacist and the researchers working in this field. But the drawback of this peptide based drug is only that it shows lesser bioavailability. So lesser bioavailability is the only problem, because they get attacked while during the metabolism step. So after adopting this solid phase peptide synthesis, what they have achieved, they have successfully reduces the solvent consumption by 71%, and they have reduces the operating time by 56%, and the manufacturing cost was reduced by 76%. So because of this innovative idea, just changing the methodology for the synthesis of this drug, they were got awarded. Now if we see the see how this amino acid based drugs are synthesized. So I have given here a schematic diagram. You can see here the blue colored amino acid, and then it is clumped with another amino acid that is yellow color, and then these two amino acids, and the small sequence is formed by protecting a group, that is amino acid one side is protected, then the resin which is used, that is a solid matrix which is needed, and then final amino acid sequence we are getting after following this method. So this is again, see, when I was thinking about what type of talk I should give, when all are already, they have already done PhDs, and most of them, maybe some of you are pursuing PhD, or some of you have done your postdoc and all. Some of you have done your postdoc from other countries and all. I know you all are having very good ideas, but I thought what new thing I should learn while delivering such lecture. So I have gone through many search reviews and articles, and then I come to know that, okay, this is, I think this is, maybe some of you are knowing about this, but this is again new for me. Then, because this is what a particular time we need to search, but because in this social media, in this era, we are just having 2 minutes videos related to any topics, but the topics which are genuinely related to our subjects and our concern, they are very less, and it is not shown in the recommendation, because we are not used to, maybe some of you are used to with all this research work. But this is, I found very interesting, that I would like to, and it is given as a reference in this particular article as well. I'm having all the references I've mentioned over here. I don't want to show here, because the same you can just see, because the contents are very large, almost carrying 160 to 100 pages. So what is important to share with you, I have just taken that screenshot and I'm sharing with you. The fifth objective is advancing sustainability product. See, till 4, we were more concerned about the inputs. And from 5, this fifth number of objective is very important, because this is not a part of only ours. That is, we are just creating reactant molecule and drug molecule or that. This part is mostly to be monitored by the manufacturers. Okay, if you see the China, the products we are importing from China, most of the Chinese products, you will see they are waste. They can't be reusable. They can't be means they don't undergo any decomposition process or anything. They are very hazardous, and I think this is the strategy where we are aware. We must be aware of what type of products we are purchasing from the shops, whether it is useful, whether it is having any such chemical composition which is hazardous for our children, for our environment. As a learned or chemistry people, we must think about it. So I would like to mention here again, it's a very big document. Out of this, I have mentioned, I have taken this screenshot. This is related to Seagate technology. I think most of us, we are using our hard disk, external hard disk, which is made up by this Seagate company. So Seagate company is very well aware about the items they are getting from the manufacturers, or the any parts. If they are in need of any parts, they are getting from any suppliers. So they have given strict instruction to the suppliers that you are supposed to give the details of all the components that we are using in the designing of any such part. So, and then the Seagate company is making all these components or composition of the material to the customers as well. Now you can see here the listed elements, the metal ions or the polymers, they are present in the hard disk, desktop hard disk. And from this we can also see that, oh, if there any hazardous metal ions are used or not. So this is the responsibility of manufacturers to take care of their products, whether it is sustainable or not. Because Chinese product is like one quote is there कि China का माल है, चले तो कल तक नहीं तो चांद तक. Means अगर वो, if it is working, it will work for longer time, or it will just get failed within one day, like that. Then second most remarkable example I have got in this document is that the very big company, and it is the larger producer of this carpets, the Shaw industry. it is a larger manufacturer of carpets. So they have reviewed their own products, and this company in 1990 they launched this initiative to know fully the chemicals and materials in their product, and they ruled out the hazardous chemicals. So what did they do? They were using PVC, polyvinyl chloride, and phthalates as a plasticider. So they have removed these hazardous components and they have used non-hazardous polymers. Then they observed that they are using antimony trioxide, which is a female retardant, but it is adversely affecting the aquatic organisms or aquatic life. So they have controlled the use of such components in their product, and they try to replace this with the biodegradable one. So this is the responsibility of manufacturer, that they must not be selfish in earning money or to expand their business, but they are supposed to go with the ideas of sustainable development goals. So again, as a chemistry, though we can't change the composition, but at least as an analytical chemistry or or the material designing people, they can go for this these ideas. They can go and do research in this field, analysis of products and material design. In most of the people, they are working in the material science. So you are designing devices, so you need to see the composition, what composition is allowed, what is the permissible limit of using any such component. It is desired, but it should be used in a permissible limit. So we need to go through these reports which has been given by UNEP. This content are very large, so I am just showing you the single pages. Sixth point is objective is related to minimize the chemical release and pollution. This is the most important and very useful component or objective that has been given by the UNEP. It monitors. See, this is PRTR. It is defined as pollutant release and transfer registries. It is a complete database system, and I would like to mention here, this PRPT is formed because of as a resultant of Bhopal gas tragedy, which was happened in 1984 at Bhopal. In December 1984, the release of toxic gas methyl isocyanate, and that gas covered almost 20 kilometers area that is away from Bhopal. And because of this tragedy, these points were considered, and the environmental act where amendments were done in the environmental acts. And you can see here what this PRTR is doing. So PRTR is an environmental database or inventory, which is observing that which chemicals are released or transmitted from the industries, and what is the composition of these chemical composition or the nature of the pollutants. Then they are also monitoring the areas from where such type of pollutants are coming out, and they are preparing the annual database and reporting. See, this PTPR is working for all the 7 continents. But out of these 7 continents, sorry, 5 continents, I would like to mention here that European countries and US countries, they are more concerned about the environmental factors. But I don't think that Asians are doing this. We don't go for other countries. We must think about our own countries. See, the loss of biodiversity, and since I'm from Maharashtra, and from that region, Vidarbha region, that too from Chandrapur district, which is very well known for its mining. And NASA has identified one small town which is just near to the Chandrapur, just 25 kilometers away from Chandrapur district, which is considered to be the second largest polluted city in the world, because the air quality index is very poor because of the open minings, steel factories. We are having industries, we are having minings, iron minings and all. So the monitoring is very important. So NASA has identified, and it is we are in very much in danger zone. So most of the people, we are having skin diseases, we are having cancer and respiratory tract disease and all. So such type of body should be made at local level as well, or district level and state level. So as a chemist student, again I would like to seek your focus on the on our part. So as a chemistry student, we can go outside in our locality. We need to identify such industries, such manufacturing companies, what type of emissions are there, and that emissions are polluting either air or water bodies or land. We need to monitor, and then we need to collect the samples. Then we can identify the pollutants, and we can make a complete database. We can submit it to the tehsil or up to the collector level, because that is the actual use of chemistry for the societal problem. So we can't go directly contribute to this PRTR database, but at least at our regional level or at our district level, we need to work in this direction. We can also develop some analytical methods. If the pollutants are known, it's okay. That is the qualitative analysis. If you want to go for quantitative analysis, then we can have a very broad area in analytical chemistry. We can develop methods for analysis of such components. I would like to mention here that we have identified recently that one of our villages is entirely affected by the fluorine content, because the fluorine content in each and every water bodies, whether it is a well or is a river water, everywhere the content of the fluoride is above the permissible limit by the WHO. So we have identified, this is our first step. Now we need to prepare some solutions so that the poor people can afford a very small device which can be used as a filter, at least just to limit the excess entry of fluoride ion into our body. So such type of problems are there. You can just identify such problems and go for it. That will definitely going to aid the sustainable development goals. The seventh important objective is that enabling non-toxic circularity and minimizing waste. So the new term, I think most of you are again aware of circular economy. So the definition of circular economy is that it is a system where materials is never considered as waste. So it can be regenerated. So what step we can take? We can reuse, we can refurbishment, we can remanufacture, recycle, or we can do some byproduct. See, one is recycling is there and upcycling is there. Under the recycling process, you can change the physical state of anything. But in upcycling, for example, see, tubes are there, tires are there. They are a very big contributor to the pollution. So one girl from Pune, what she has done, she just understood that this is a problem, this is a pollutant. So how we can upcycle this product? So she has used those tires for designing of footwears. So now she is sending her brand, and she is using tires as the initial component for designing footwears. So circular economy is based on elimination of waste and pollution. It wants to circulate the products and regenerate the nature. So the last sentence is very interesting. In our current economy, what we are doing, we take materials from earth, make products from them, eventually throw them as a waste. So this process is entirely linear. Mathematically, if you see, it is linear. But we need to change this plot, and we need to take all these things in the circular manner. In circular economy, by contrast, we stop being produced, waste is stopped being produced at the first step only. So circular economy is again is more focused in US countries. The review which I have showed you in the first or second slide, there they have mostly they have considered circular economy when they are observing their research protocols which are adopted by the chemistry people. So this circular economy is again the factor that has to be considered while our designing your research proposal. The eighth part is that is maximizing social benefits. See, maximizing social benefits is it is the expectation from our field. As a student of chemistry, we are having organic chemistry, inorganic, physical chemistry, analytical chemistry, material science, environmental science, and biochemistry, everything. Lots of fields are there. But we need to work together. We need to take help from zoology people, from biotechnology, from physics, as well as all the fields, even from the arts background, even from the economics or commerce background. So social benefits so what we can do for the social benefits? First of all, we need to identify the problems. So as a chemistry student, I don't want to go to the hospitals and want to see that which type of disease are more prominent in particular region. So you can take examples, you can take help of our sociology students, so that sociology students will directly deal with the people of people from any communities, and they can produce data for you, that what type of research you can do for what type of work you can design for solving these issues. Then as we are teaching at the college level, we can organize one program where we can directly go to the school. We can share our thoughts with our students, that too students with different age groups. You can't explain everything green chemistry to the peers, to the student of 6th standard or 8th standard. So we can group such people, and we can have sessions for environmental concerns and awareness regarding polythenes. Most of the people, what they are doing, they are just collecting all the waste and they are burning all the polythings, and they are still standing in front of it, and they are just inhaling all these toxic gases. So such type of practice is very common at every house in our country or in our state. So as a teacher, or as a as a literate person, we can just give awareness related to the environment, or related to the medicines. Overdose of medicines are there. People are just searching Google and taking medicines. They are not consulting teachers. So Google doctor is not it's not going to solve your is not going to cure you. But such type of means sessions we are supposed to take, so that we can directly reach towards the society. And the main problem is that we are supposed to listen to our society, where we are having farmers. What problems our farmers are facing, that is our responsibility to listen them. What is the problem of any school teacher? What is the problem of student? What is the problem of any working culture? We need to listen them, because we know that government is just sending new policies, just sending new just agreements, that you have to do this work, you have to perform this project, and like that. But sometimes government should listen to us. If government is doing any amendments in the educational policy, they are supposed to ask us what type of education we need. The educationist, or the people working in the various areas, whether it is in education or in any field, in research related to drugs, or it is related to solving societal problem, we need to listen to the society first. Then only you can redefine your proposals and your problems. This is the data has been coded over here, but I'm not showing it, because it is again having, I think it is having 100 pages. So the ninth objective, it is very important: protecting workers, consumers, and vulnerable population. See, when sustainable development goals, it tells about the life, the person who is working must get the decent salaries, or the eligible amount, or the whatever amount has been already prescribed by the governments. But at the same times, we are supposed to be concerned, since we are dealing with the chemistry field. So we are supposed to get concerned of, if our student, if our colleagues, they are working with such companies who are producing any, for example, just like Minamata disease, everybody is aware of this disease. This is because of the people who are working in the mercury based industries. They are getting suffered from Minamata disease. So you can see when the people are dealing with such toxic chemicals, so they may get affected with the neurotoxic problems, they may get affected with the reproductive disorders and cardiovascular disease or endocrine related problems or nephrotoxicity and cancers. Because most of the organic compound, they are also considered as carcinogens. So as a chemist, what we can do? We can contribute to this particular region. We can devise mask that will stop inhaling such carcinogenic compounds. We can design such gloves, we can design such materials or the clothes which can be used as a apron or a uniform for these people. So there are lots of areas where at very small scale we can just contribute to contribute for the betterment actually. The last and the important objective is that developing solutions for sustainability challenge. Here, it is very easy to seek what type of research we are supposed to do. Now, this document again, it is of 100 pages. This document is giving you an idea that what key research is to be done, what are the hotter topics or the topics that is to be chosen, and how you can do the collaborative work. So they have pointed out certain sectors like health, biodiversity, and climate change. Sorry, in case of health, we can how we can contribute. We can go for the designing of new drugs, of course, that we are doing. We are helping pharmaceutical industries for designing of for the synthesis strategies, and we can also help them to find out the mechanism which is responsible for disease. So the smart work or the computational chemist, they are also doing this work. Then we can go for the biodiversity conservation. See, this biodiversity conservation is not possible for us at single level, single faculty. We need to seek help from biologists and zoologists, because they will identify the species which are undergone extinction, or they will identify the species which are endangered. They will identify the species which are medicinally important. Because since I'm working in this region which is considered as a the tribal region of the entire state, but this region is having this region is rich, having rich biodiversity. This region is having rich mineral deposits. But nowadays some companies, they have already started planting their making their plants, and the mining is undergone, mining process is under progress. So we are losing many such means distinct plant species which is exclusively grown in these areas. And these tribal people, they are having very good knowledge of their therapeutics, and they are using these species as a for treating many of such diseases. Since they are just claiming and they are also treating, but the exact mechanism for knowing the means mechanism of action, that is the again a very good area of research. And they there we need to we can work. And I would like to mention here that there is a database already in the, you can go and search IMPACT, IMPPAC, that is the website where the phytochemicals present in the particular plant species that has been documented. So you can use that database to see the species which is medicinally important and what type of chemicals which are responsible for showing biological activity, and they are yet not identified. So you can collab with CMAP, that is Central Institute of Medicinal and Aromatic Plants. So you can collaborate with these people so that you can just identify the active pharmaceutical ingredient present in your extraction. And you can go with, again, with the help of computational chemistry and softwares, you can directly go for the designing that particular molecule as a drug. Then again, sustainable consumption, and there are various topics are there. You can go through the list. I have just taken these two parts, but document is very large, and you can you can read it in depth. The data is given is it's a very good data, and the time has been utilized more for reviewing the data, that what type of content I should consider and should get shared with you people. And I think I tried to communicate that ideas to you people, so that even if you see, now you are having a very comfortable job, but out of so many problems, if you can design, you can develop one project, and if you can solve very simple very major problem of our society, then I think as a literate person, as a degree holder, or as a researcher, we can make our subject useful for the society. Because when if you are going to the to take sessions with the school children and college students, we need to make them understand that why this chemistry subject is important. Because in NEP there is a problem that lesser number of students are taking this opting this subject chemistry, because they are not understanding the importance of our subject. So it's a high time that by means of such programs or such interactive sessions, you can inculcate such ideas of thinking and use of chemistry in their day-to-day life. So this was my actual idea to convey this message to all of you. And I think maybe some of you are already well known with these ideas, but some of you may be new for just like me, and you may got an idea that what changes you can do with your research work. Since I am also working with lanthanide chemistry and biophysical chemistry, so again I would like to mention a very personal thing. I would like to mention here, I have synthesized many lanthanide complexes, but till date I was awarded PhD degree in 2017. And again I worked in during my postdoc with lanthanide complexes. Some advances I did in the methods and products, but still I am carrying all those products and chemicals with me, because I am very much afraid of disposing all these chemicals directly to the soils or putting it into the sink. So now I am thinking that no, I will not go with this traditional work. I will try to identify such problems, basically local problems, and try to use some new ideas. So this is my idea of defining a research problem. Maybe you are having some other ideas, so you may go for it. So I would like to conclude here that green chemistry definitely tries to support the UN sustainable development goal by minimizing the pollution at the source only, source itself, and maximizing the resource efficiency, replacing toxic chemicals with renewable alternatives, and to build sustainable global economy. So by utilizing these principles, which sustainable developments can be addressed. So sustainable development goal number 3 that talks about good health and well-being. Of course, our field is vigorously working for designing good drugs and targeted drug deliveries, and then designing of good materials based on biodegradable substances. Then water and sanitation, that is comes under the sustainable development goal number 6, where of course as our subject we are contributing for analyzing pollutants present in the water, and then developing methods for the water. I know most of the material science students, what they are doing, they are preparing one composites or nano composites and all they are preparing, and then they are going for removal of dye. See, there is a difference between removal of dye, there is difference between degradation of dye. As a student, I understand degradation of dye is more important as compared to identification or adsorption of dye. When the dye is adsorbed, when you are taking out that dye from the water, when the dye is adsorbed on your material, then what is the fate of that dye? क्या करोगे उसका? So we need to go for the methodology where you can develop idea where your dye is getting degraded, because dye is entirely organic molecule. If it is getting degraded, then last component will be either water or either water, H2 or CO2, like that. The product will be in that terms. So this area, you people are getting lot number of papers and very good citation number, but to be very frank, I am not considering this because this is a very traditional work. But if you can design a device which is helpful for degrading the drug, degrading the dye, then it is good. And one more thing I would like to mention here, we can see how this our government policies or government, I'm not ashamed of taking names of these politicians. While doing all their campaigning, they are using huge number of hoardings. As a chemistry, I'm always complaining that why they are using so much number of hoardings for the advertisement. Which type of dyes they are using on the hoardings? After one after one event, they are changing the hoardings. And where they are going to keep that old hoardings? How they are getting replacing these old hoardings? Are they using any method for reuse? These questions that arise and striking in my mind, that the manufacturers and the industry people and particularly businessmen, you are supposed to think about what you are producing. If you are a selfish man, if you are making money for today, then what type of environment you are creating for your coming generation? This is a very big problem. I'm very much getting irritated by seeing lots number of hoardings in our entire city. So this question we are supposed to raise, and government is not completely aware, because one of a very our very famous person in our locality, Shantaram Podduke, he used to say in his talk that there is lot of politics in education, but very less education in the politics. So that is the reason we can't expect good thing from them. But as a student of chemistry, as a student, as a teacher, what we can inculcate good habits in our coming generation, in our present generation, that we need to think about it. Then affordable and clean energy, of course, our most of the researchers, they are working in the field of production of energy, and production of energy, then conservation of energy, and then energy conversion. These three major factors where, of course, government is also giving very good response for projects who are writing projects in this regard. But when I attend one conference which was held at Nagpur University 3 years back, scientist from TIFR, he has given very good design for production of hydrogen gas, and they were transferring that technology to DRDO for the commercialization. And we know that H2 or hydrogen can be used as a very clean fuel for energy production. And there are two types of hydrogen, one is blue hydrogen, one is green hydrogen. The difference is that what inputs you are using for the production. So we know that we are working, but there is lots of lacuna in our research and the societal needs. So we need to build up that bridge, that we are supposed to resolve the problems, we are supposed to address their problems, and then come to the conclusion that okay, whatever research experience or the things we have learned while performing our research activities or pursuing PhD, everything, characterization and synthesis and using of apparatus, knowing about the MSDS of the chemicals, all these concepts can become useful for us for directly solving the societal problem. So with these words which has been given by UN Secretary, he told that the sustainable development progress is not only about lines on the graph, it is about healthy mothers and babies, children learning the skills to fulfill their potential, parents who can feed their families. It is about renewable energy and clean air. It is about the world in which everyone enjoys human rights and human dignity. So, with these words, I would like to conclude here and stop my presentation. And if you have any doubts or any sort of small discussion, now it is open for all of you. Thank you. Oh, I can see Riyadh sir.
Good evening, ma'am.
Good evening. Good
Very
evening.
good evening, ma'am.
Ma'am,
Hello, sir.
I want to ask the phytochemical database you were saying, na? We can get the phytochemical.
Yes, ma'am. I will share that website with
From
your
where?
coordinator.
Yes, ma'am. Please do share. Please do share.
Yes, sure, ma'am. I will share it.
Oh.
Definitely.
Thank you.
Okay.
Ma'am, I want to ask one more thing. If I want to work in the direction of nanoparticles
Yes.
from green plants, nanoparticle synthesis using green plant extract, and those plants are also
Yes.
from some rural area, which the rural people are
Yes.
using these days, but they
Yes.
don't know how to, their effectiveness is less, na? So, can will that database be helpful for me? Because
see, ma'am, see, when you are working with this field, using plant extract for synthesizing nanoparticles, okay?
Yeah.
So the first parameters that you are supposed to consider is that whether the species you have selected is having antioxidant property or not. Okay. So if it is having antioxidant property, definitely it will help you for getting nanoparticles. That is the first parameters you need to consider. Then
okay.
Then you can go with this website where you will get the composition of phytochemicals, that what type of phytochemicals are present in that particular plant species. You will get structure. Yes, you will get structure of the compound, and you will get references as well, that where it has been already reported. But the best part is that first you go with finding out the antioxidant property. That will ease your work actually, because
Thank you.
is the question. This question is basically asked by the reviewers, that which phytochemical is responsible for showing this reducing property.
Yeah. I can understand.
Yes.
Thank you, ma'am. Thank you so much.
Thank you, ma'am.
Oh, ma'am, good evening.
Good evening, sir. How are you, sir?
How are you, ma'am? How are you? I am fine.
I'm fine,
really,
sir. Very nice to see you.
happy to see you after a long gap.
Yes, sir. Almost, I think after, I think 10 years, I think 10 years.
Yes,
10
yes,
to
I think more than 10 years. But lucky, I am so much lucky that you are on this platform. And I have joined this refresher course and listened to your lecture. How are you, ma'am? Fine, na?
I'm absolutely fine, sir. I'm working at Gondwana University. I'm staying in Maharashtra only. So, where are you
Maharashtra
right
where?
now?
Maharashtra where?
Chandrapur district. Chandrapur district.
Okay.
It is my hometown actually, hometown. But working in Gondwana University.
Oh, okay. Actually, I saw your profile now, but I thought I will call you later regarding this. So nice to see you here on this platform. I just have a question. I have gone
Yes, sir.
through
Definitely,
slides.
sir. You are such a learned. I am very happy to see you, Bapre. That's why I told you in the first instant that many of us may be senior. I have just completed my 2 years, sir. I'm very much senior academically as well as.
Oh, I know your caliber. I know your hard work, and and now I am very much happy to see you here. Really.
Okay, I am also very much happy to see Bapre. Riya, sir. I was just surprised to see you, sir.
Thank you. Not surprised. I am also in
Yes,
Mumbai only. You know, na?
Okay. Yes, sir.
I'm in Mumbai only.
Yes, sir. You are in Mumbai. I tried to get your number from Gohar, sir, but I didn't have your number. But now you can have my profile. I will search you. No issue.
Sure. Now we will be in contact. Sure.
Yes. Definitely. I need
So,
your help, sir. Yes, sir.
not a question, just a suggestion. And because I
Yes, sir.
saw you are a lot of book and know a lot of knowledge, but I just wanted to know that regarding the AI. how AI
Yes.
can help us to improve the efficiency of chemical upcycling of the plastic waste into some usable or valuable products as regards the sustainability point of view.
Sir, see, AI, in my view, if you are using AI that is the licensed one, then licensed one will give you an appropriate data. Okay. So if you're not using licensed one, what it will do, it is a faster engine, search engine. It will just collect data, whether it is relevant to your search or not. Okay. So we as a student, see, we are coming from that era when there was no AI. So we were used to go with all the literature. So best part is that we need to go with the core literature or good research papers, those who are genuinely working at ground level. So AI will only help you to get data, but it will not help you to solve any such problems. This is my experience.
We take help from the AI because
Yes.
for last few months I was going through few papers regarding AI and this environmental sustainability, and I could not see that part in your lecture. Just had a suggestion and from your side, and very nice and fantastic presentation from your side.
Okay, thank you, sir. Sir, this is the first time I'm interacting with such a huge crowd. Listeners are there, and
Very
they are
nice,
from
very
various
nice,
areas.
very nice, really nice.
Thank you so much, sir.
Yeah, thank
So,
you.
sir, you can have a licensed one, licensed AI. You can use licensed one. They will provide you better data.
Okay.
Licensed, yes, licensed AI.
It is a paid one, na?
Yes.
It is paid.
Paid one. Yes, sir. Licensed is paid one. That only one you can try with paid one. Then you can see the difference. What the free is giving, what content is free is providing you, and what is there in the licensed one. But again, we have to go backward to the research source only, sir. Research paper source that we can't leave it.
Sure.
Okay.
Yeah. Thank you very much.
Thank you so much, sir. Sir, you are still working with electrochemistry?
Yeah. Electrochemistry and supercapacitor. Our field is now supercapacitor.
Oh, so you are working with Bahar sir as well?
Yeah. We have a lot of work together.
Okay. Nice. Very nice.
He also purchased one electrochemical workstation.
हाँ.
Metro wala.
हाँ.
Yes.
Hello.
Yes.
Yes, sir.
Gauhar sir had also purchased one that electrochemical workstation, Metro.
Okay.
He's also working.
You were not audible that time. That's why.
Okay. Yes. He's in contact with me, and he used to come Mumbai also.
Okay.
Yeah.
Now we are at the very means zero. We are at the zero ground. We need to develop entire department. So I seek some help from your side, sir. Definitely, I will contact you.
Sure. That is what is need of the hour. We have to do everything interdisciplinary, and then the
Yes.
problem can be more effectively solved.
Yes, sir.
Sure.
Okay. Thank you so much, sir.
Thank you.
Any other questions?
Good evening, ma'am. I just want to say thank you for your
Thank you,
approach
sir.
of presentation and highlighting the importance of green chemistry regarding the thinking of the greener way of pursuing the chemical reactions or something. Just I want to just mention one thing that you are showing one slide that is the solid phase peptide synthesis.
Yes.
Peptide synthesis. So I actually do this for 3-4 years during my postdoc also, and that is by handling the reagents or something like that. That is not a very I don't know if you know deeper about that. Just to mention in the passing for the participants as well. So although I am integral part of that research for many years in PhD postdoc, but I am no hesitation to admit that is one of the most hazardous process, because that most of the chemicals that is not a very efficient reaction, because we have to you have to use the peptides, the amino acids that is used. They are mostly used 4 times that we need.
Yes.
and also the bases that are used like piperidine and some other bases, all the coupling agents, they are mostly quite toxic because secondary amine is quite toxic. So that's why the peoples are trying to minimize, set up conditions to how to minimize the amount of the reagents, chemicals that is used there, because that is not a very efficient reaction and absolutely not an environmentally friendly process. That's solid phase peptide synthesis. One of the most important classes of synthesis that chemists do.
Okay.
For the protein synthesis, chemical protein synthesis.
Okay. But for that particular drug, they have designed this method actually. For that particular
for
drug,
drug, yes, for drug or many
particular
drugs and many peptide things, because if you want to synthesize some proteins, so two ways. One way of if it is a not very bigger size, and if you want to do lot of modifications, then it is best way to chemical synthesis. That's why that's when solid phase peptide synthesis is used. And the other way is obviously the bacterial, using the bacterial mechanism that is called the protein expression. Protein expression is another way, so by cell culture. And the chemically used, if you want to make chemically the proteins, that is the most common way, solid phase peptide synthesis. But the problem of that is it is not a very environment friendly. So people are using some different methods, trying to use some different methods, but still now that is the most common process used, but that is not absolutely not environment. So that is one of the target of the green synthesis, those who are looking for the green synth pathways to how to modify the solid phase peptide synthesis. So thank you. For your
Thank you, sir, for sharing this data, because I was reading this entire content. So it actually, this reference is already given in the their main document. That's why I referred this one.
Yes. This is a very common process actually for peptide, but the problem is that what I already mentioned.
Additionally, we are doing this protection and deprotection. That is also not allowed in green chemistry. Protection and unnecessary protection and deprotection is also not allowed. But that's a simple. I would just like to give this as an example, not to adopt all this, but this is how the methodologies are modified. So they have given the reasons that what are their achievement. They have reduced the consumption time, production was good, and the solvent need of solvent was less. So they have mentioned that, and on the basis of their performance and the results, they have been awarded actually. Like that. That's why, and this example was already given. That's why I've mentioned.
Yes. This is a very good, actually very good. What I already mentioned, the target. So how we can modify this process, so make it more greener approaches for this.
Yes.
Thank you.
Thank you so much, sir. Thank you so much for sharing your experience and your research experience with us. Thank you, sir. So any other questions or suggestions or any points would you like to mention here or share with the rest of the participants? Then it will be better. I can understand everybody is now just exhausted because after going such a vigorous sessions for the entire last 10 days, maybe all of you are exhausted. This is the last lecture, I think.
Yes, last one.
Yes, sir.
This is the last lecture.
Yes, sir. This is our last session. Yes.
This is last lecture. Yes.
Yes, I got your schedule yesterday only. So I think 2 sessions were there, and this is the last one.
Yeah.
Yes, sir. So hope you have done your refresher course very nicely. And sir, you are such a senior. Now you are professor, I think. Vyas, sir.
No. I am due for associate professor, and for associate professor we have to do one refresher, na. So this was left actually.
Okay.
because this is my 11th year in service, and
11th year.
coming June I am having the due date for this
It's a due.
associate professor. Yes.
Okay.
And when did you
So,
join there?
sir, I joined here in 2023, just 2 years back. 23. So,
Yes,
shall I stop or what?
Any further questions? If there are no questions, then we can conclude.
Yes, sir.
Thank you, ma'am. I think it's Dr. Vyas sir's turn to propose vote of thanks.
Okay.
Sir, I think someone else is there for this, and if no one is there, then I can.
Yeah, yeah. So I will check it. Only wait for 1 minute. Yes, Dr. Saroj Bala madam is there.
Yes, sir. I'm here.
Yeah, please.
Okay. Good evening to all, respected course coordinator, Madam Manisha Kodape, distinguished speaker, Madam Dr. Sneha Ramdas Wankar, esteemed faculty member, and their participant. I, on behalf of the organizing committee, MMTTC, Sangade Baba Amravati University, Amravati. I extend our sincere gratitude to our respected resource person, Madam Sneha, for delivering such an insightful and thought-provoking section on the sustainability blind spot, redefining the research gap in green chemistry. Madam delivered a topic on minimizing chemical hazard, non-toxic circularity, and minimizing waste, and many more. Your valuable presentation has deepened our understanding of sustainable chemistry, highlighted critical research, and inspired us to explore innovative and environmentally responsible scientific solutions. We are truly grateful for the time, knowledge, and expertise you have shared with us today. I also express many heartfelt thanks to our organizer and all the participants for their enthusiastic presence and active participation, which make this session meaningful and successful. Thank you once again to everyone for your valuable support and contribution. We look forward to many more enhancing academic interaction in the future. Thank you all.
Thank you so much, ma'am. I would like to thank all the organizing members of all the organizing committees and for giving me this opportunity. I'm very much new for this such type of session. This is the very first time I'm delivering such talk. Thank you so much. Thank you all the participants for listening.
Thank you, Dr. Sneha. Thank you so much. And this is a platform to build, and connect all faculty members across the country from the different domains and different disciplines to this. And we are really luckily fortunate that you have shared your precious time here to enlighten us on such a very different topic that will be correlated to this chemistry and ultimately our education purpose. So we are really thankful to you, ma'am. And please stay connected to MMTTC Sant Gadge Baba Amravati University for such a futuristic academic assignments and other assignments also. Thank you so much, ma'am. Thank you so much.
Thank you.
And
I want to add one line, sir. Here, I'm very much thankful.
Dr. Yes, sir. Yeah, please.
Through this platform, I could contact Sneha, madam. I am very much happy, sir. Through this platform only. Thank you, sir. Thank you very much.
Actually, Riya sir is my senior. Actually, we were doing. Sir was doing PhD while he was doing PhD. I was a MSc student, and we have completed our PhD from the same university. And sir completed his postdoc from Mumbai, and I completed my postdoc from VNIT. That's why we are having same profile. But sir is very much away. Means he's a very good researcher. Actually, he's working in electrochemistry. I think yes. Electrochemistry and designing of this super capacitors. So I know sir is a very, very brilliant researcher as well as he's a very good teacher.
Thank you, ma'am. Thank you very much.
Thank you so much.
Therefore, ma'am, I have said that this is a platform to build together and stay connected, because the researcher and the faculty members, those who have exchanged their ideas on such kind of platforms, that will be really appreciable. And one of the important thing is that whatever may be the contents that has been developed through this refresher course, we are percolating through a YouTube channel that is directly connected to our MMTTC portal, that is the Malvi Mission Teacher Training Program portal. And that nationwide this researcher and scholar that get connected through the different type of courses. So all the participants are there, and definitely that will be very beneficial for us, because whatever maybe the sessions you have conducted here, not only you, all the experts that they have conducted the sessions, they are directly connected to near about 15 lakh faculties across the country, ma'am. So we are really thankful to you, ma'am, once again. And with the kind consent of Dr. Sneha, ma'am, I would like to declare that today's session will be over here. Thank you so much, ma'am, and thank you, participants. And gentle reminder for your assessment, as we are in the final phase of this refresher course, one task is there left remain to complete by the participants. So there will be MCQ test too, and that has been scheduled in the summer. So you can access from 5:30 towards. And my best of luck to all the participants for their MCQ test. Thank you, everyone, and we'll meet tomorrow. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Thank you.